So we'll start with the course now. First, before diving into SQL, we need to know what is DBMS, right? So DBMS is nothing but database management system. Okay. Now, what is a database management system? It is nothing but you have your data and it needs to be managed by a system or a set of instructions or a set of rules, right? That is what DBMS is. So if you see in this diagram, which is very well explained, so what we do have here is the relational databases. The databases is what we have here. So we have relational database, we have hierarchic database, we have flat files, or we have the objects, right? So these are nothing but the databases that we have which can store data, and data can be stored in any form. When we say relational is nothing but where you have data stored in the tabular format. So you have multiple tables and each table is joined to the other table using some relation. So it may be a salary and an employees table, so both the tables are joined using the employee ID. Okay. Or you may have a hierarchic database where you will have the highest table may be the college. For example, if you take a college system, so the highest may be the college, then below that you can have the multiple multiple tables such as the employees, the teachers, the students, right? Then we have flat files, which is just, for example, an Excel file, right? A flat file. Or you have objects database, right, where your data is considered to be objects. What are objects now? So for example, you have a car. Okay, so a car can be of various models. Okay, now automobile, if you now consider, automobile is something which anyone can use to go from one place to the other. That is a generic class. Now, what are the types of automobiles you can have? You can have cars, you can have trucks, you can have buses, and there are many other things, right? So each of them can be considered as an object. Okay. I hope we are clear on what is the databases, the types of databases we can have. We can have many others, there are various types of databases right now in the market. So these are a few of them. Okay. So this is where my data is stored, right? This is the place. Next, we have the storage area. Okay, this is the storage area. DBMS lies between the storage area and your front end, right? So you have the back end here and you have the front end here, and this is where your DBMS lies. So what it does, it acts as an interface between the database, okay, which is stored, and the applications which you are using to access the database, right? You can't, if you are here, right, if you are the end user, you are a user here, or you are the application, so you are the user, you are using this application, you can't directly access this database. You can't, because data is stored in a very raw format. We can't do that. It is stored in a very mechanical form where you would need machine codes to access. Obviously we cannot. So we have DBMS who does this work for us. It will know where the data is stored, which we want, and it will pull that data for us. Okay, that is what DBMS does. So the interfaces which this DBMS can cater to are this. See, the first is applications. Okay, so for example, you are using some SQL, MySQL developer or SQL developer. Okay, or you are using Microsoft SQL Management Studio, right? So those are the applications by which you can access your DBMS. Or you are users who are directly, accessing DBMS. So you are using some website, for example Amazon, right, and it is accessing the database. It's its own database, right? So that is how you use as an end users. Or you can also, one DBMS can be connected to another DBMS. So sometimes this is also is needed when you have multiple databases scattered across various places. You will need multiple DBMS to interact with each other to give the user the data needed, right? Then these applications will come on top of other DBMS. Okay, so this is how your data is stored. Okay, and our data is accessed using DBMS. I hope the DBMS concept is clear by now. So we move on to the next part. Okay, next we'll see what is an ER diagram. Okay, now if you see, we spoke about the relational database, right? Which is a relational database management system is a type of DBMS with a row-based table structure. Most commercial RDBMS uses SQL. Okay. Now, what is an ER diagram and why are we talking about RDBMS for an ER diagram? Okay. Now, like I told you, RDBMS or a DBMS, okay, relational database is nothing but RDBMS. Okay. Now, when we say RDBMS, if you see, we have different tables here. If you see, we have different tables here, and each table is connected to each other, okay, using a relation. Okay, so for example, if you consider this table to be employee and this table to be salary, an employee table can be connected to the salary table either using the employee ID or using a department ID, for example. Why I am saying that? It can be a case that each department has a specific salary. Now, anyone in the employee table who is working in that department will have that salary, right? So, that is how tables are interconnected to each other. Okay. So, this is nothing but a DBMS, but each of the database is connected or each of the tables are connected to each other using a relation. That's why we call this as a relational database management system. Okay. And what is an ER now? So now you know why it is called RDBMS, right? We previously you know what was DBMS, then you understood what is RDBMS, and now we will see what is ER or entity relationship diagram. Now, entity relationship diagram is nothing but where each of the entities or so tables are also called as entities, right? So each of the entities are connected to each other via relation. Just the way I told you, like how tables are connected to each other using relation, same way entities, which are actually nothing but tables, they are connected to each other via relation. Okay, so these are ER diagrams. When you write multiple tables or multiple objects and you connect each of them with some relation, and there can be multiple, each table can be connected to multiple tables. For example, if you see this table, this is connected to all these tables using some relations. Now, there can be different kind of relations. Okay, there can be one to one, there can be one to many, there can be many to one, and there can be many to many. So note down, these are the four types of relations that can happen in between any tables: one to one to many to one, and many to many. Okay. Okay, so now we have a fair idea of what is a DBMS. Okay, how the tables are connected with each other. Okay, so we know all that. Now we will see what is SQL. So before I start with SQL, we write it as SQL and we pronounce it as SQL. And why we pronounce it as SQL? Let me just show that to you. Okay, so SQL is nothing but structured query language. Okay. Okay, so when you are studying, okay, if you're studying, if you're in college, you will generally call it as SQL, like you will call with individual letters. But when we work, we call it as SQL. SEQUEL. Okay, so if you see QUEL and SE, okay, so these are the things which is used to call it SQL. So now going forward, you should practice calling it SQL because that is what it is called in industrial terms. Okay. Okay. So what is SQL? SQL stands for Structured Query Language. SQL lets you access and manipulate database. Okay, let's first concentrate on the first 2 points. Okay, SQL is called the structured query language. Why? Because query is nothing but you are querying your database. Now, for example, there is a table. Let me give you an example of a table. Okay, imagine this is a table which is also stored in our database. Well, this is, I going forward in the class, I am going to show you where and all it is stored. But right now it is an Excel. Okay, so just imagine we have this table in the Excel, in the database, and I want to know the answer of my question, which is how many people are there in my employees table, or how many employees do I have. So what do? I can just take a count, right? I can just take a count and I can say, okay, I have 108 employees who are, part of my employees table. Okay, so what I did first, I asked the question, how many employees are there? Okay, same way I can query, or I can ask my database a question, which is a query, and database, or the database management system, which is the DBMS, what it will do is it will return the answer to my question. Okay, through the application I am using, whether I am using a browser or any software like SQL developer or anything, right? So it will return it there. So this is a query which I am asking to my database returns me an answer to that. So that's why it is called a query language. Why it is called structured? See, English has a grammar, right? English language or any language has a grammar. Now, when I say for SQL, it is nothing but very plain English, right? Every syntax we use there is just English, which is structured a bit differently, okay, to get the results. Now, that's why SQL has its own grammar. You can consider SQL as an English language itself with its own set of rules for grammar. You are here to learn only those rules, and that's it. Because SQL is so easy, it's just English language, plain English language. Okay, just the grammar is different, and that's what makes it different, right? So that's why it is called structured, because it has its own grammars and own rules, and it is a query language. So that's why SQL is nothing but structured query language. Okay. Now, SQL lets you access and manipulate database. Now, what does that mean? SQL will let you access a database. That is, you can get hold of your data. You can pull data from your database, right? So if you want to know that, okay, how many employees do I have? You can write that code in SQL, and you can send it to your DBMS. DBMS will fetch the data for you, and it will send you back, right? So you are here, ask your DBMS using SQL. SQL is the language which DBMS and the user understands, right? SQL is the language which the DBMS and the user understands. So you write the code in SQL. Now this code is interpreted by DBMS in a form which the database can understand. This is a database. This database. So DBMS, what it will do is it will interpret SQL, the language, in the form which the DBMS can understand or the database can understand. Okay, it will fetch data from there, and it will pass it on from SQL to the end user. That is why it's called, you can access database as well as you can manipulate your database. Now, what does manipulation means? So, for example, there are students in a class, example class 9. Now the final exams are over, right? Recently we had 10th exam for the boards. Now everyone has to be moved to one class higher. Now you need to change the classes, right, for the students. Now previously they were in 10th class, now they will be going to the 11th class. Are you going to enter new records for all the students over and again, where you already have the data of the students? No, right? what you're going to do is, you already have the database of the students, you are just going to increment the class number. So previously they were 10, they were in 10th, now they are in 11th. Okay. So this is how you manipulate your database. Next, SQL became a standard of the American National Standard Institute. Okay, SQL became a standard of the American National Standard Institute, which is the ANSI, in 1986, and of ISO in 1987. Now, why is this point very important? SQL can become a part of any institute. How does it matters to us being the end user of SQL or being the data analyst, right? How does this matters to us? Now, see, in market we have various kinds of SQL languages, right? So for example, you have Oracle, you have Redshift, you have MySQL, you have NoSQL, you have many things, you have big data, you have many such SQL languages. If you see after this session, just go and Google, okay, what is the difference between Oracle SQL and MySQL. The syntax, mainly see on the syntax, what you will see is there are no major difference on the major part of it. Only the syntaxes here and there changes. The way maybe a date is written in MySQL and Oracle SQL and T-SQL. T-SQL is nothing but Transact SQL, which is used by Microsoft SQL developer. Okay, so the syntax is where it changes. Rest all of things are the same. So if you know Oracle SQL, it will be very easy for you to know any of the SQL languages, whether it is MySQL, whether it is Redshift, which is from Amazon, or whether it is T-SQL by Microsoft, right? Any of the SQL languages you have, you can very easily learn and adapt to, because there's literally no difference in the basics. To make this happen, that there shouldn't be any change in the basics, okay, this was integrated to ANSI and ISO, so that the basics remain the same and standard across any of the languages. That's why SQL is added to the institutes, and that's how this matters to us. Okay, so I hope we are clear on what SQL is and how it is a standardized language. Okay, now we will start with main the main crux of this course, right? I know everything was theory earlier. uh Now we will go into the practicals of it. Okay, we'll actually see how things are working. Okay, we will be actually querying the data and taking the data from our tables. Okay, before going into this, I will tell you how will you be running the queries. Okay, so what you need to do first is open your browser. Okay, open a new tab. Okay, now go to Google and type in Oracle Live SQL. Okay, so you go to Oracle Live SQL. This is the URL. If you want, you can type also livesql.oracle.com. If you type this much in your Chrome or any web browser, you will be good to go. Otherwise, you can also Google up and this page will open. Okay, so this is where you can start your coding. Now see, Oracle has Oracle SQL Developer. There is MySQL Developer. There's an interface there. We have SQL Server Management Studio, where you can write codes for T-SQL, right? There are many things, but there are limitations to those when you are learning SQL. Okay, I'll tell you the limitations. Now, one thing is when you are doing it through a software, you are restricted to only that machine. Now, for example, you are a student and you don't have a machine of your own. If you are, wherever you get a machine, you practice. If you have an account and you access your account through a browser, you can open your account anywhere in the world, through any place. okay, through any computer, and you can start practicing and learning. Whereas if you do that using a system, you are restricted to that system only. One more issue, okay, one more issue, if you are working with a system, uh sorry. So one more issue if you are working with a system is you have to install the software. Now installing a software is not that hard because you have YouTube tutorials and everything to guide you how to install a software. But then not every time you're successful. There are issues with with the systems. Okay, each one of our system might be a bit different, and then not everyone's system is compatible. We might have low RAM or the low requirements than what is needed, right? And then we can't install. So accessing through the browser is the best way you can access your tutorial, or you can write queries, you can practice, right? Okay, so you want to go to this place, okay, and you need to sign in. Now if you don't have an account already, what you need to do is you need to create an account. Okay, so once you click on sign in, okay, this is my own personal account. Now if you don't have an account, you need to create an account. Okay, you will create an account, and once you create an account, let's see, you need to fill in these details. Okay, so you need to put in an email, password. Okay, you need to be aware of what are the limitations of the password, and you need to fill in accordingly. Okay, then country name, job title. So if you don't have a job right now, so you can put student as well, it's okay. Then you have the phone number, okay, and then company name. So if you're not working, you can always write you a student. You can put your address. You can be less specific, okay, it's not needed you need to put your complete house address. Okay, you can be very less specific by only giving the place you are from, and the city, and the state, and the zip code. Okay, and then create the account. Okay, by this you will create an account. Most probably you will get a verification link on your mail ID which you provide. Okay, in this mail ID you have to go and you have to verify your account. Once you verify your account, you are all set to work on SQL. Okay, so once you verify your account, you are all set to work on SQL. Okay, now because I already have an account, I'll just sign in. Okay, sign in. Okay. I'll just take it to the dark theme. Start coding. Okay. Okay, let me just restart it again. I think I have some issue. Yay, by God's grace, I have logged in. Okay, sometimes I'll tell you that there are sometimes issues with Live SQL. It might show you some problems. Just try it again. So like I switched off my browser, I closed my browser, and I restarted. So sessions and IDs, this kind of things happen. Okay, so that's fine. You can always retry, and you can like close and you can open. Okay, now let me give you a walkthrough of this SQL worksheet. Okay, this is nothing but live SQL. okay, which is provided by Oracle for students to learn SQL better. Okay, you have many other places where you can do it online. You have W3 schools and many other places, but this is by far the best place where you can do your SQL coding. Okay. Okay, so this is where you write your queries. Okay, this is the worksheet. Then if you have written some query here, so for example, let me write a query here. Select star from table. Okay, this thing, there is a query. I will explain everything later. Now you want to clear, and you have many such queries written here right now, and you want to clear your worksheet, so you can click on clear. It clears out. Next you have find. So if you want to find about a table, employees, okay, so employees, so you have read only access to HR sample schema, which is fine. So the names of the tables that we have here is countries, departments, employees, employee details view, jobs history, locations, and region. So the tables that I have in the HR database, which is human resource database. Okay, the HR sample schema. And if I want, I can go into each of the table and I can have a good view of the table. Okay. Oh, there's a thing called copy query. So if I copy the query and I go here and I paste it, it is nothing but it is selecting everything. I'll tell you what this means. So basically your query was copied here. Okay. Now, next thing. I'm just running it because I want to show you some other things as well. In some more time, I will show you how to run and everything. Okay. Okay. To run a query, okay, either you write the query first and then you click on run, or you press Control Enter. Okay, if you press Control Enter, your query will run. This is the place you have your output. Okay, you have your output in this place. So you see these are the columns, okay, and these are the rows. Okay, now if you go extreme down, you see 107 rows selected, which means there are 107 records or 107 employees in my employees table. Now, if you want to download this data in database, then you click on download CSV. Once you click on download CSV, I click here and you see my data is downloaded now. Okay, so whatever output you see there, that will be downloaded. Whatever output you see here. Now, one quick tip on this, when you use live SQL for the first time, your output will be restricted to 50 rows only, 50. Your output will be restricted to 50 rows only. Now, to change this limitation, what you need to do is you need to go to this actions, maximum rows preference. Here right now I've set it to 200 for mine. If you are for the first time, you will see it is in 50. You can put to 200. That is good enough for you to work here. Because 100 you can't, because 107 rows we have in employees. Okay, so you can put to 200 and that should be fine. Okay, next thing, actions. Okay, now when I want to show for, when I want to see the current session. See, I have not logged out till now, right? After I've run these queries. So I've run only one query right now. So if I want to see what are the queries I have run in this session, that is before after the time I've logged in during this session. So what are the queries I have run? I click on view session and I can see all the queries I have run and their output as well. Okay. So this is the query. It will run. It will give you this data. Okay, if you would have run multiple queries, all your queries would be shown here. So right now this is shown as statement 1. If you see here, this is written as statement 1. You can go first, you will have statement 2, statement 3 like this. You can sort in most recent or the most recent first or last. Okay. If you want to only see the statements, just click on this and your results will be hidden, or only the results, or both statements and results. I generally keep it here. Then include all statements. Do you want to see all the statements which you have run in this session, or you only want to see the errors? That means the query which errored out, or you want to exclude the errors and you only want to see those queries which actually ran. Okay, so you can use this. Okay, you can edit the query now, right now here, by clicking this edit. You can run this query once again. Okay, or you can delete this statement. That is, you don't want to keep a history of this statement, so you can delete this as well. Okay, so this is for the current statement, sorry, a current session. Okay, now if you go back again, okay, so we have something called as, okay, I'll show that later. Before that, we have something called as shown line numbers. There's nothing but this line numbers, auto close brackets. So if you have brackets, then that will be auto closed. This is the font size. You can increase or decrease as per your needs. Okay, then whatever showing you is your session. So this is the current session, right? If you wanted to see the previous session, so you go in this three lines. Okay, just next to live SQL, you have 3 lines. You go there. Okay, and you click on my session. Okay, you see everything you have in this session. Again, you can rerun this query, the complete session from here. You can replace the script, you can delete statements, or you can download the scripts as well. Now, if you want to see the previous sessions, you can do these for the last 10 sessions which we have done. Okay, so if you see last session was 6 days and 2 weeks and 3 weeks. Okay, like this we had the sessions. Okay, so now the current session is 46 minutes ago I logged in and it's still in use, right? The current session is 46 minutes over and still in use. Okay, so if you want to see a previous session, so for example last session, or maybe if you're a student and you're thinking, okay, yesterday I ran some scripts, I want to see which script did I run. So you can always go here and go view session and you can see which were the queries you ran in last day. Okay, okay, let's go back now. Okay, so now you know how to navigate through SQL, right? And now we will see how to use the interface to write queries. Okay, so everything that we are going to learn will have a syntax. Okay, it's okay if you don't understand the syntax right now, because syntaxes are difficult. When I was a student, I also felt it very difficult to understand the syntax. So what we'll generally do is we will see the examples quickly after looking at the syntax, so that with the help of example you can understand your syntax as well. Okay, now if you see this, writing basic SQL select statement. Okay, okay, now SQL has two operations. Okay, two famous operations: selection and projection. Okay, there are no notes on it, but I will tell. So if you want, you can write when I am speaking. So there are two things: selection and projection. Projection is nothing but where you are projecting the data you have. Okay, and projection deals with columns. Okay, projection deals with columns. So for example, I want to, if you see here, we have a table. Okay, this is a table where my data is stored. Okay, I want to show all the columns that we have in our table, right? If I want to show all the columns we have in our table, we put a star. So star indicates all. Okay, remember this, star indicates all. Okay, so if I want to show all the columns I have in my table, I use star. Now, if I don't want to show all the columns that I have in my table and I only want to show specific columns, I mention the names of the columns instead of putting a star. Okay, so I tell select department ID, comma location ID. Okay, so I've specified I only want these two columns from my table. So it will only show me these two columns. Now, this is called selecting because we are selecting data. Okay, but technically this is called projection. Okay, selection means when you are selecting which rows to show. Okay, so remember this, selection deals with the rows, projection deals with the columns. Okay, once again, selection deals with the rows, projection deals with the columns. Okay, this is how selection and projection works. Okay, right now we'll see how to fetch some data. Select identifies. Okay, one more thing, um each of these are okay, so this is select and this is from. Okay, so select identifies what columns. Okay, like I told you, select identifies which columns you want to show. From identifies which is a table from where you want to show. Okay, table is nothing but, like I showed you, it's a collection of rows and columns. For example, this employees is a table, and there we are dealing with departments table, right? So departments is a table in our database. I showed you just now, right, how we get data from the employees table and we can download the data, and I opened it in Excel, right, for you to see. By doing this for all the tables, right, I have put their data in each of the sheet. Okay, so this is how I got my data for departments. Okay, and if you see, we have 4 columns here: department ID, department name, manager ID, and location ID, right? Now if I write select star from HR dot departments, is my spelling right? Let's check it out. And it ends with a semicolon. Now, semicolon, I'll tell you, semicolon is not necessary when you are just writing one query, it is fine. But when you have multiple queries, then you need a semicolon to separate one query from the other. Okay, colon is used when you want to separate one query from the other. Otherwise, without semicolon also, your query will work fine. At least here. There are some places where semicolon is mandatory, differs again from language to language. You need to understand that, or before you start working, right? You, for example, people like even me, I have changed multiple companies in my career. Now, in my first company, I used to use Oracle. In second company, I used Amazon Redshift. Okay, right now I am using MySQL. Right, so each of them has its own set of rules, which minutely changes from one another. So before I start off with any new database, right? So what I do is I just Google out, I see what are the differences I have in that database, and I'm good to go, right? Okay, so this is nothing but the select clause. We call these as clauses. So select clause, you can write if you want all the columns or if you want only particular columns. Then from clause, in from clause we write from which table we want to pull our data from. Okay, from says from which tables we want to pull our data from. Now, if you see this example, select star, this pipe is nothing but or. Okay, so whenever you see this pipe, it will be or. So either you can just put a star, or you can put the column names, like how we have it here. Okay, how we have it here, select the column names. Or we can also put expression or the alias. Okay, alias along with the expression. Alias you can put along with a column as well. We will see what is an expression and what is an alias. For now, you just understand that we can also write expression along with alias or a column along with alias, okay, in the select statement. Or we can just write a star which will select all my data, all the columns, right? Distinct, you see distinct is in a square bracket. Anything, so it's a rule. Okay, anywhere you see a word or a keyword basically which is written in a square bracket, right, it means that that keyword is optional. Okay, that keyword is optional if you have something in the square bracket. So distinct is optional. Okay, we will see later what distinct means. Okay, so if you write distinct, that comes before the column or the expression. Okay, now you know this. Now let's query this. Select star from HR departments and you get all your data. Okay, so you get all the columns which you wanted. And since we have not done any filtering on our data, we get all the rows. Now, if I just want two columns from here, okay, which is department ID, comma, department name, and I run. So I just get the two columns which I want to show, right? With department ID and department name, I just showed the column which I want to show. Not every column is being pulled here. Okay, this still remains the same because we have the table name here, and because we are pulling this column from this table, this will not change. Okay, now let's see some interesting facts about SQL. SQL statements are not case sensitive, which means you write select in small or in capital, it won't matter. Okay, next thing, okay, and it won't even throw an error as well. Okay, SQL statements can be one or more lines. So, like if you have seen, I have written it across two lines, which is okay. Until you put semicolon, SQL will consider this as a single query. So that's why semicolon is must. Keywords cannot be abbreviated or split across lines. Now, what does it mean? I can't put a space and segregate or split this keyword because select is a keyword, right? You can just put SEL and this in the next line, ECT. You can't do this. This is wrong. Clauses are usually placed on separate line. Like I told you, these are clauses. So generally, these clauses are put in separate lines. Okay, this is better. Indents are used to enhance readability. Now, what are indents? The space that we have here, right? So which is called indentation. For example, for the clauses like select and form, we don't have any indentation. But for the column names, I have put an indentation here. So if you also want, what you can do is like this. You have the column names and you have a proper indentation here to show, okay, this falls under this clause. This falls under this clause. Okay, to show the header or the superiority also, we can use uh, formatting our query into next lines or using indentation. Default heading displays uppercase. Okay, so you see whether you even if you ask only for department and in department name in small letters, right? SQL will always show this to you in capital letters. That is how SQL is built. Okay, I hope you understand this part till now, where we are querying the data. Okay, next thing what we will see are the arithmetic expressions. So if you remember in the select statement, we had expressions and alias, right? See expression and alias. So we'll see what are expression or alias. So basically, these are nothing but you may need to modify the way in which data is displayed or perform calculations or look at what if scenarios. Okay, these are all possible using arithmetic expressions. Okay, now what is a net arithmetic expression? It is nothing but an expression which can contain column names. Okay, so you can put the column names or you can put the numeric values, the constants, and the arithmetic operators. So these are the operators which you can use to calculate, right? So we have the basics here: plus, minus, multiply, divide. Okay, now when you have such thing in a number, okay, so if you have plus and minus both, which one will be the first? So that is done by the operator precedence. Multiplication, division, okay, it takes the priority. And then we have addition and subtraction. Okay, so after multiplication and division we have addition and subtraction. This is how the precedence is. So if you have multiplication and addition in a single expression, multiplication will be done first, and then with this result addition will be done. Okay, operators of the same priority are evaluated from left to right. Parentheses are used to force prioritize evaluation and to clarify statements. Okay, now in a same expression, if you have both multiply and plus and divide and minus and everything, right, it becomes difficult for you to understand, okay, which is actually working fast or first. Okay, then for that what we do, we use parentheses, okay, or the brackets that are used to force the prioritized evaluation to clarify the statements. Okay, let's see some examples here now. Okay, so if we want to see some arithmetic operators, so select last name salary and see salary plus 300. Okay, so it should be the table employees because department doesn't have the data. Okay, so in the employees table, what I pulled out is name, salary, and salary plus 300. So just imagine 300 is a bonus which was given evenly across to all the employees. Now, if you want to see, okay, after the addition of bonus, what will the data look like? Okay, that is when we use this in the select statement only. Okay, from the table, HR employees. Okay, next thing, operator precedence. Now, like I told you, if you have multiple operators in the same line, so 12 into salary plus 100. So what will happen, because multiplication comes first in our board mass rule. So basically, the operator precedence is nothing but the board mass rule. Okay, which we have learned during our schools. So see, last name and salary is still the same. What we are doing is we are multiplying my salary with 12. So first I am multiplying it with 12. and then I add 100 to it. So what this will mean is I am multiplying my salary. Okay, like I am getting the yearly salary, and with the yearly salary, I am adding 100, which is not correct, right? If we want to actually wanted to see, okay, if I increment my salary, okay, the employee salary by 100, then I want to see what's the total expenditure in the complete year, which is 12 months. So in the down on the last example where we have salary plus 100, we see we have parentheses coming in. Now again, parenthesis is always the first thing to be evaluated, right? So whenever you have a parenthesis, that is the first thing which evaluates, instead of like in spite of many others being there. In BODMAS rule, B comes first, which is bracket. Hence, bracket is evaluated the first. So first we evaluate salary plus 100, and then we multiply it with 12. Okay. So next thing, okay. So next thing what we will see is the null, null value. Now what is a null value? A null value is something which is unavailable, it is unassigned, it is unknown, or it is inapplicable. Okay, so null is something where there is no value. Okay, so it can be anything. Okay, even if it is a zero, that is a value. If it has a it just have a space, that can also be considered as a value. But if something, if a cell has nothing, that is considered to be null. As simple as that. Arithmetic so now why we are discussing this is, you have to keep in mind when you do arithmetic expression containing a null evaluates to null. Okay, so basically what happens is, in your data you have data like last name, job ID, salary, and the commission percent. Now every employee does not get a commission percent, only a few of them gets. Okay, now when you run this query, what happens is, let's run actually. Select last name, job ID, salary, and commission percent. Okay, now I run this. So you see, for many of them, we don't have commission percent, right? Now, if I want to multiply this commission percent with any number, right? Salary is never a blank, and 12 is a constant number itself, right? So if I want to multiply a null with a numeric value, or an arithmetic expression, then it will result to a null. Okay, that is how the behavior of null is. Okay, so to eradicate, what will you do? That it should not turn into null. Okay, so you can either represent or tell that, okay, for every blank, let that be replaced by 0. Then at least you are counted here. Otherwise, you show as invalid identifier. Okay, so next thing what we will see is defining a null value. A null value is a value that is, okay, this we saw actually. Defining a column alias. Now we learned about alias, right, in the first slide where we were seeing the syntax of SQL. Okay, now alias is nothing but it renames a column heading. Okay, so it's renaming the column heading. Okay, remember this change is only a cosmetic change. Okay, nothing is actually being done to a database. No changes are being done to the database. Okay, so what column alias does is it renames a column heading. Okay, it's useful with calculation. So if you have a correct column alias which is very small and only as per needed, then It will be useful with calculations because most of the calculations are huge, okay, and you would need somewhere, okay, something to validate. So it is useful with calculations. Immediately follows the column page, the name. There can also be the optional as or the as keyword between the column name and alias. Okay. So basically what this means is whenever you are, putting in column alias or you are renaming a column, if you see this example, right, we have an as here, which we can remove. Okay. So last name and the okay, last name as the name, commission percentage as com from HR.employees. Okay. Requires double quotation marks if it contains spaces or special characters or is case sensitive. Now, why would we need double quotes? Now, sometime back we learned that the headers for column is always in capital letters, right? Whatever you might put, if it's a small, or if like it is camel case where only the first letter is big and rest of all are small, okay, so that will not happen. Okay, that is not how SQL would work. Either you need to put just like as, and everything else will be in capitals, okay, because that's how SQL works. And also, if you put last name as name, then what happens is you are just renaming the last name to name with N capital and AM is small. Now here we, in the example also, we what you will see is we are getting this name as the column header instead of having the complete name with names in capitals. Okay, because we have double coded it. Again, this goes same for this annual salary. Now, like there is a ground rule for naming some columns. One of the ground rules is you should never ever have a space between your column names. If you do that, your query is wrong. Okay, but now there are sometimes needs, right, where we need to write the annual salary. Okay, so what do we do there? We have done 12 into salary is annual salary from HR employees. Okay, so next thing what we will do is the concatenation operator. Now, what is a concatenation operator? A concatenation operator, this is a this is an operator which what it does, it concatenates or it joins the columns or the character strings to other columns. Okay, so basically you can join two columns together, or you can join two characters together, or you can also join columns and characters together. So whichever way you want you can do, but just use this concatenation operator. Okay, it is represented by two vertical bars. Okay, like I told you that a single bar is nothing but or, and double bars where we put, that is a concatenation operator. Okay, and then it creates a resultant column that is a character. So whenever you are joining, even if you're joining to numerics, the one when you join, that is called the resistant column, that is a character. Okay, then we have literal character strings. A literal value is a character, a number, or a date that is included in select list. So if you write, okay, 10 as commission percent, okay, so because most of them doesn't have a commission percent, but you want to put the number 10, okay, so that is called a literal character. Okay, okay, remember one more thing here, that we have another function called as concatenate, okay, which concatenates values. The limitation with that and this is, but concatenate you can't have more than two values, okay? But with this concatenation operator, which is double bus, you can achieve this. Now let's see how concatenation is used and how nulls are used. Okay? So last name and job ID we concatenate and we get the employees table. Let's for now remove this. Okay, so you'll see this is the result that we got. Last name and job ID. So last name is able and job ID is SA rep. Now, if you want to show it more properly, what you can do is so you see what I've done is nothing but I have put a space okay between two quotes and I have added it with the double quotes to my main data. Now with this what happens is we actually getting able which is SRF. Now this data is much clearer to me. Okay, this is what concatenate data is. Now there's another form of concatenate which is done using a function which is called concatenate. Now the difference or the main difference or the limitation between concatenate function and concatenate sticks are here you can have multiple columns and strings as you want, but for concatenate function it is only the function where we have only two inputs and two outputs. Okay, I hope this is clear. Next thing which we have is the null values in arithmetic expression. Now last name, okay, what we are doing is select last name is a then concatenate is a job ID as employee details. Now this kind of data you will only get in your company database, right? You will not get anywhere. So what we do is we select last name and then we put quotes and then we put job ID. Okay, so the next thing which we will see is eliminating the duplicate rows. Okay, now in the first slide when we were learning, we were starting with SQL queries. We saw in the syntax we had distinct keyword. Now we will see what is the use of the keyword. Okay, okay. So when we see for the duplicate rows, let me just quickly show you some example. Okay, so right now in the employees, okay, I have this column job ID. Okay, if you see in this job ID we have okay, so in this job ID we have many rows with ST clerk or SA man or SA rep, right? There are many such rows. But the issue is if I just select job ID and I want to see, okay, how many job IDs do we have or what are the unique job IDs we have in the employees table? Okay, what do we do for that? So we select just the job ID. Let me just select that. So you see each of the job IDs are being repeated. Okay, because for each row there is a different job ID, right? And they are going to be the same job IDs for multiple rows. Now this is not serving my purpose. I want to see the unique job IDs. So what I do in that case is I use the keyword called as distinct. Now, when I use distinct keyword, what happens is I only see the unique job ID. So one job ID will appear only once in my data, and if there is a null will come always once. Okay, null always comes as once. So what I see is we have 19 rows, which means we have 19 unique job IDs in my data. Okay, this means we have 19 unique job IDs in my data. Okay, so this is the use of distinct. Okay, so eliminate the duplicate rows by using the distinct keyword in the select clause. I hope this is clear how we, restrict data. Okay, so this was one of the parts that we have completed now. Okay, from the next, this is the next chapter where we will see how do we restrict and sort the data. Okay, so we will see how do we restrict and sort the data. Now, before going into this, one quick thing I want to show here is if you have a table. So right now you are very well accustomed with the table, right? You want to see what are the data, what is the columns we have in the table. Okay, so right now we did see one way, okay, where we were we were looking into how the table looks like and everything. Okay, but there is another way how we can show this. Okay, that is using a query. And what do we, and for that, what we do is HR.employees. Okay, so we have this, the DS is nothing but describe. Now what will this do? If you write a table, okay, after the keyword describe, it will show all the columns, okay, in the table if the column is null or not null. Okay, and what type of column is that? Okay, this basically shows you the table structure. Okay, so employee ID is what is the column. Can this employee ID be null? No, this cannot be null. This concept is called constraint. Okay, this concept is called constraint. Let me just write this for you. You can, if you are interested, you can learn more on this constraint. This is what constraint. We have many kind of constraints which we can have on our column. We can have not null, we can have not blank, we can have a list of values constraint, which means, so if your target audience is in India and you have a table which you have a column which only takes the states from which the employee belongs to. Okay, you should only be allowed to enter Indian states because your market audience is India. You can't put US audience. Okay, so that is a list of value constraints or a range constraint, right? There are many types of constraint. If you want, let me just show this to you. Constraints in SQL. Okay, just go through it. You will have many constraints. Okay, okay, so this is how you describe your data or describe your table. Now let's quickly go into the next topic. Now if you remember, before starting this I told you about two concepts of selection and projection. Projection is where you project your columns but you select all your rows. Okay, there is nothing with the rows there. But when you say selection, selection is where you are selecting which rows to display. Okay, Now, when you say you are putting a filter on your rows that you display, so basically you are putting some conditions, right? Okay, for example, this is my employees table, and this I want to show only those rows, okay, who works in um maybe account. Okay, it's only one. Let me just take something else. Um, ST clerk, let me take. Okay, so for ST clerk, I have 21 rows, right? So I want to check, or I want to display only those rows which works in job ID ST clerk. Okay, so what do we do? So let's write the query. Select start. Right now, let me select everything. So basically, I am projecting all my columns. Okay, from HR.employees, where job ID is equal to ST clerk. Sorry. Is my spelling correct? ST clerk. Okay, everything will be in caps. Clerk. Let's see if this works. Yeah, this works. And let's see how many rows do we return. We return 20 rows. Okay. Now, so the data, the version which I am using is a bit different. Okay, let me just remove this ST clerk. This is actually not needed. Okay, so how many do we have? We have 20 here, right? Even if we see here, also ST clerk, so you have 20 rows, right? That is what we are getting here. We are getting 20 rows. Okay, so basically what we did is we selected data and we only selected that part of the data which we need to show. We don't need everything. We only need a particular job ID's data. How did we do that? After writing our select and from clause, I have written one more clause where. Okay, so where helps us to filter out data. Where, after where we put the condition. Okay, so for right now my condition was where job ID is ST clerk. Now remember, I said earlier that SQL is not case sensitive, right? But if I would have written here ST clerk, no data found. Why? Even though I said SQL is not case sensitive, this is because in SQL, whatever you write like this, okay, like the column names, the keywords, okay, all these are not case sensitive, but the data is case sensitive, okay? So whatever you pull or whatever you write inside the single quotes or double quotes, those are case sensitive and will be, matched exactly same to same with the same case as well. So we need to be very careful when we are dealing with data because that needs to be case sensitive, because that is case sensitive. Okay, so we should always be sure about the case that we have. Okay, next thing, when we say data values, okay, we are putting a single quote, right? We are putting single quote. Now when we are putting single quote, um, we sometimes tend to get confused on, is it a single quote or it's a double quote. Okay, like I myself, I have been confused for a few years when I was learning, when I was working, that where to put a single quote, where to put a double quote. Now a very easy thing it's a very easy rule. Okay, whenever you are using a value, remember this, whenever you are using a value, whether it is in the where clause or anywhere, it's a value which is present somewhere in the table, okay, or maybe you are doing some manipulation, but it's a value, it will always be in a single quote. This is a golden rule. And when do we use double quotes? whenever we have to put an alias of a table or a column, we use double quotes. Very clear thing. Whenever we have to work with, or whenever we have to rename a column or rename a table, we use double quotes. Rest everywhere we use single quotes. So keep this in mind whenever you are confused with between single quotes and double quotes. Once again, double quotes are used whenever we are working with or renaming tables or columns. Double quotes. Rest everywhere single quotes. That's it. Okay. So this is how you pull data. Now this was a string. Okay, this st clerk was string. If you want to pull out a numerical data, okay, so let's see some numerical data here. Department ID, right? We can just pull out department ID 50. So department ID 50. Now whenever it's a numerical data, you don't need quotes. You can write without the quotes as well. Okay, I hope this part is clear. Whenever it is numerical data, it is without quotes. Whenever it is a character data or a date, okay, it should always be in a it should always be without in single quotes. I hope this is clear. We will move on to the next thing. What do we have? Okay, so whatever I told you, same thing. So character strings and date values are enclosed in single quotation marks. Character values are case sensitive. Default date format is DDMONRR. Okay, now the date format in Oracle is DDMONRR, which means DD means the date, which is 01022825. Okay, MON means the first three letters of your month. So for example, you have March, so it is MAR. You have May is three letters, so it is MAY. Okay, or you have June, so which is JUN. Okay, so this is how your date is written, and RR is year, like 0305, which is 2005, or 2023, which is 23, will be written here. Okay, so this is how we restrict data. Okay, and this is the syntax. From select and from clause syntax you already know. Okay, but where is something that we learned. Moving ahead. So right now we learned, okay, where we equated, right? We had job ID is equal to 50, or job ID is equal to, we had ST clerk, or department ID we had 90 or 50. Okay, so we did an equal operator. Okay, we have many such operators that we can use. Okay, so this is where we do the comparison. And so for one, which we saw just now is equal to, then we have greater than, where we see the greater. If something is greater, the value is greater, we will see each of them in query. Okay, and we will see how each of them is working. You can always write down, you can pause the video here if you want, and you can write down the conditions that we have. I'll quickly show you the all of them in queries. So select last name, comma, salary from HR employees, where salary is less than is equal to 3,000. Okay, let's run this. Now what this will do is it will select all the rows where the salary is either less or it is equal to 3000, right? In this, it will select all the rows where the salary is less than or is equal to 3000. Now, before moving on to the next, next comparison operators, one thing I want to point out is we have HR. Always when we are writing a table name, we are putting an HR here. HR is nothing but the schema. Okay, I will discuss about this more in later course, but in case you are wondering what is this, why are we writing HR? So HR is nothing but the schema. After we are done with the course, I will discuss on why are we doing this. Okay, so just keep in mind it is just a schema. You need to put HR dot employees. Okay, so any table you are using here, you just need to put HR dot employees. Okay, okay, next part. So this you saw how we use less than is equal to. Okay, same you have greater than equal to. Okay, whenever you say both greater than or equal to, it will include the value you are putting and it will go above it. Okay, then what else do we have? We have um greater than. Whenever you put only this, it will not include the value you are putting. Okay, then not equal to. Not equal to means it will pull all the rows except the rows where the value equals. Okay, so it is just the opposite of equal to, not equal to. Okay, then we have some other comparison operators also. Okay, which is this between and in, set, or like. Okay, so how does this works? We will see more on them. So let this be, this last name is comma salary of employees. Now I want the employees, okay, or the records where the salary ranges between maybe 3000 and 4000. Okay, so how would I have written if with this? So salary less than equal to 3000 and salary greater than equal to, sorry, if I say in between, it will be greater than equal to 3000 and salary salary less than equal to 4000. So if I do this, I will get all the rows where my salary starts from 3000, which it includes 3000 and it ends up to 4000. So if anyone has 4000, that will also come. If anyone has 3000, that will also come. And all the salaries that are between 3000 and 4000, that will also come. Okay, so sorry. Okay, so this is how we would write when we want these records. And how many records are we getting here? We are getting 19 rows, right? Now, this is a tedious task and it is a bit confusing. Instead of doing this, what we can do is we can just write salary between 3000 and 4000 and we run it. So what do we see? We still get 19 rows. So it is basically the same of what we were doing earlier. Okay, salary between 3000 and 4000. Okay, so previously it was this. Okay, we did it this where salary is between 3000 and 4000. A very simple way of writing, right? This makes our query more good looking. Okay, what I did here is I commented out this line so that this line is not recognized by our interpreter when running the query. So this is just a comment. Okay, how I did it? So there are ways of commenting. This is something important, which you should understand very carefully. Commenting is when you don't want that thing to come up, or the interpreter to tell that okay, this is a code it should learn. So comment is something you can write anything you want to. Generally comments are written to make your code more readable. So for example, I have a big query right now. It is a very small query, but you have a very big query with multiple tables, multiple joins, multiple columns, and many things, right? You want someone to understand okay what that code is doing, what that query is doing, okay, by a single look. What you can do is always you can just put a comment here by putting um, two two hyphens. Okay, now again this commenting way differs from language to language. So from Oracle you have one, from MySQL you might have something different. So just see what are the comments for that particular language. So here we can have this, which is called single line comment. Okay, or you can have a multiple line comment. Okay, so you can write hi, hello, and you can write many things here. Okay, okay, so this is multiple line comment, and the one which I told you earlier, single line comment, you can put a comment to any line with a shortcut of control and forward slash. So I will just write it out, control and forward slash. So if you press both this together, your line will be commented or uncommented. Okay, cool. So this was about commenting. Kind of brought it in between of doing the conditions, but this was something important. Okay, so I hope you understood that. Okay, coming back to the conditions that we were discussing about. So we were saying how between and can be used instead of writing two conditions here. Okay, next we have something called as the in condition. Okay, so what is an in condition? I want to see all the employees who work in department ID. Okay, and I don't want to see this time in a single department ID. Last time we saw only where department ID was 50, but this time I want to see 40, 50, and 60. We have 51, right? Okay, 40, 50, and 60. We want to see all the employees working in these three departments. How do we do? For this, we can use the in condition. Department ID in 40, 50, and 60, right? Okay, there is an error. Okay, so see this, whenever you have an error in your query, the error will be showed. Okay, at the end here where you get your data or the output, your error will be showed here. So you have, so because I selected last name and salary, so right now I'm getting all the rows where department ID is 40, 50, and 60. Same 51 rows is what we got here, 51 rows, right? So again, like I told you, when you have a list of conditions, you can use in. When you have a single condition, please use is equal to. Okay, and when, because in will take more time, then you can do it in as well with a single condition, but it is always advisable you use is equal to for single condition. And like in single condition also, when you use a string or a date, you need to use single quotes. Same goes for here. If I want to see all the rows where my job ID is maybe SA rep and SA man, I have 35 records, right? So what do I do? Job ID in. Remember that case is important for us to see. Okay, 35 rows. See, I hope this is clear now. How are we are doing this? Okay. Next thing, what we see here is like. Okay, we just now saw what is in. Next, we will see what is like condition. So like is, when do we use like? So like is when you are not sure about the complete data, okay, but you know a part of it, and then you want to query based on that. For example, you want to see, so if my data is this, okay, I want to see all the job IDs which starts with A. So if you see, we have multiple job IDs which is it starts with A or F, H, I, and many other things S. Okay. So I want to see my all the job IDs which starts with A. So what do I do? Select. Let me select distinct so that I only have the distinct values, not each value repeating multiple times. Job ID from HR employees, where job ID like. Okay, now I will be using like. A, like I said, always value is case sensitive. So capital A percentile. Let's see what all did we get. We got account manager, assistant, press, and VP 5 rows. Okay, so let's check this here. 1, 2, 3, 4, 5. Right, we have 5 job ideas with A. Now, what it did is just now is it it told, okay, I want all the data or all the job IDs which starts with A. Percentile means it is okay. Percentile is nothing but a wildcard character. Now, what is a wildcard character? When you don't know what values will come in and you want to put a placeholder for that value, that is called the placeholder is called a wildcard character. So here you can use two wildcard characters. Either you put a percentile, which means zero or many. So it can have zero value. It can so if job ID only had A in it, that would also have been pulled. Okay, job ID had only a percentile, like only at one value, A, S, for example. So that would also have been pulled. Okay, and like it has multiple things, so that also multiple letters after it, that is also being pulled. So percentile means zero, one, or many. Okay, now there can be a case I know that there are two values. So any data which has two values after A should be pulled. Okay, now how do we do that? So let's have some thing. Okay. Okay, so we have two such last names where we have after A we have three letters, right? Able and Andy. Okay. So what I do is I put three underscores, and this is actually last name. So let me change to last name. Okay, so you see when I run this I get able and Andy. Why? Because I have put three underscores here. Okay, so because I have put three underscores, I get only those records where I have three letters after A. So A being one of the letter, rest we have 3, and that's why we have put 3 underscores. So remember, underscore always means you need to have one character. It can't be 0. It should be a character. And it should only be one character. So each underscore represents one character, and like I said, there should be a character. You can't go without a character. Okay. So I hope this is clear. How are we doing? How are we picking up wildcard characters using like? You can have it anyway. You can have it before a. Okay, so for example, you want such last names which has a anywhere in it. So what you do, you put percentile a percentile. What this will do, this will pick all the last names which has a somewhere in it. But also, just remember, because we did a small a, it will not pick up any such rows which has capital A in it. Okay, remember that it will not paste any such row which has capital A in it. It will always pick the small a's. So in that case, this rows, right, like Atkinson. So if you see Abel and Atkinson, Austin, this 4 will not be picked up because this had capital A. Okay, Austin. But again, if this had a small a somewhere, this would have been picked up. Okay, so this was about the like condition. Okay, next what we will see is null. Okay, now null is, like I told you earlier, null is like it is a value which is not, it does not exist. It is neither blank, it is neither a blank space, because blank space is considered a value. Okay, so that is what null is. Okay, how do we see, how do we get null values? So if you see in our data, this is the column which is null, which has nulls. For output purpose, for output sake, Oracle displays hyphen, one hyphen, where null is there, but actually it is null. Okay, so let's take this up, select staff from HR employee, where commission percent is null. So you see, I get all the rows where commission percentage is null, where we don't have any value. Now just the opposite. If I want all the rows where commission percentage is not null, so basically the employees which are getting commission. Okay, so I just put a not in front of null. Is null, is not null. Okay, so here if you see, all the rows has got a commission percentage here. Okay. Okay, same goes for like and between. So when I said, okay, let me just go back to my session, view session, and let me go to the, okay, this is, so the, let me just pick out statements only. Okay, this will be easier for me to navigate. So when I said is null, it is not null, right? Now, same way here, we wanted all the last names where my last name had a anywhere. Okay, like a small a anywhere, to be more precise. Now I want all those where I don't have a small a anywhere. Okay, so what do I do in that case? In that case, let me just copy this, and I won't edit it here. Let this be here. Okay, so here I just put not like. Now it will pick up all the last names where I don't have a small a. See, these are the capital A, and capital A and small a are different. if this is a uppercase, this is lowercase, right? So they're not same. That's why we're getting this. So these are all the last names where we don't have a, small a. So whenever you want the opposite of something, just include not. Okay, like for null, not null, like, not like, between, not between. Okay, that is how you can put. Okay, next what we have is logical conditions. Okay, which is and or not. Now, what are logical conditions? This is something few of us might have learned during our school or college days. Okay, so we have this. So we have inputs. Okay, I'll just show you a truth table quickly. Okay, now 0 0 0. Okay, so this is a truth table which we learned during our school days. A few of us might have learned and few might not have learned. So I will teach you from the basics. So just imagine 0 being the false and 1 being the true, right? So a true value and a false value of zeros. Okay, so when I have this kind of a value with 0 being the false and 1 being the true, if I want to find out the result, if x and y are joined by the operator and, okay, same we will see. Okay, and same we will see what happens when x and y are joined by the operator or, and not works on a single operator. So we have x here. Okay, let's see how this works. So when x and y are joined by the operator and, the 0 and 0, we have 0. So false and false is 0. Now, when the output is false or 0, one of them, but another is true, right? For and, it is false. Why? Because for and, the logic is even if a single input is 0, the output will be 0. Again, if we're here for x and y, we have y as 0, x as 1. So because y is 0, this will also come as 0. Like I told for and, even if single input is 0, the output will be 0. But here again, we have both 1 and 1, with both are uh, ones, right? Both inputs are 1. So the output will be 1. Okay, so remember this part whenever we are doing for x and y conditions. Okay, 1 0 0 0 1 1 0 and 1 1. Okay, when even if single 0 is there, the output will be 0 for and. Now, contrary to this, when you go for or, whenever here also, for the whenever we have all of them as zeros or all are false, the output will always be false. Now, in and, what happened is even there is a single 0, the output was 0. For or, how we say is even if there is a single 1, the output will be 1. Okay, so we put 1 here. Same goes for here because x is 1 here. So we put 1. And again, because both are ones, both are correct, so we put 1. Okay. This is how and or works. Now, not works, not nothing but negation. Okay, where we negate the value or the input which we get. Now, not of x is the input. So if we take 0, so not of 0 is 1. So basically we are just taking the opposite of what we are getting. Okay, again, x of 0 is 1 and here x is 1. So we put 0 and here also we put 0. Okay. So not is nothing but where we are negating the input. This is what it's being showed here, but because this is in letters, so it becomes difficult for us to understand. This truth table is kind of easy, so if you want, you can note this down by pausing it here. Okay, we will see some examples now how this is working. Let's have an example where we want the data. Okay, select maybe the employee ID, last name. Okay, that's and salary and job ID. Salary and job ID from employees. Okay, till now we generally had given one condition per query, right? Now we will start giving two conditions. Okay, so now I want to have two conditions when my salary is greater than 5,000 and my department ID is 50. Okay, let's do this where my salary is greater than 5,000 and department is department ID is equal to 50. Okay, how many do we have? Okay, let me just select department ID. It will be easier for us to see. We have 5 rows. So if you see in all these 5 rows, the department ID is 50 and the salary is greater than 5,000. Okay, so this is how we speak in English as well, right? If you would have asked someone, okay, give me the data where the salary is greater than 15,000, 50,000 and department ID is 50, you would have spoken it in English in a similar way. Same thing, what we are speaking in English is what we are writing in SQL as well. Hence, in the beginning, I told SQL is nothing but English, but with a different grammar, right? So salary is greater than 5,000 and department ID is 50. So only when a row satisfies both the conditions, which I am putting it here, only then the row is eligible for the output here. Otherwise, no. Okay. Only when a row satisfies uh, the conditions I have given here, only then the row is eligible for output. Otherwise, it is not eligible for the output. Okay, so this is how AND works. Okay, now let's see OR. Okay, so if I just put OR here, let's see what happens. How many rows are we getting? Oh, we are getting many. 98 rows selected. So what does this means? This is basically either your salary should be greater than 5,000 or your department ID should be 50. If either of them is true, you are eligible to be displayed. See, even if both of them are true, still you are eligible for displaying, right? But for OR, even if one of the conditions you're putting here is true, you are eligible for being displayed. Okay, that is what OR is. Now remember, right now I showed here only with two inputs, X and Y. So basically you can think this to be the X and this to be the Y, right? You can have multiple such conditions. So I have put for salary and department ID. You can also add job ID, where salary is 50,000 or department ID is equal to 50, your job ID is equal to something, ST clerk or something, right? And then what we the next condition is not. So not, I have explained you sometime back when we were doing for like, in, and between, right? So we use not. Okay, so that is what not is. Okay, next what we see is the order by clause. Okay, now what is order by clause? So you have your data, right? So sort the rows with the order by clause. AC is the code for ascending order, and this is a default order. So if you don't mention how to order, SQL will order ascendingly. Or if you want it to be sorted or ordered descending, so you have to mention DESC. Always remember the order by clause comes last in the select statement. This is an interview question which we generally get when you're a fresher, or even experienced people also get this question. When is order by clause comes in the query? Order by always comes in the last. Okay. Now let's see an example. Okay, so we have select clause, from clause, where clause. Now I'll put order by clause. Order by salary. So now you see my salary is ordered 21,000, 22,000. See, it's sorted ascendingly because I've not put anything. If I want to put, if I want to sort it descending, so I after salary I just put descending. Okay, now you see it's sorted descending order. So the highest comes first and then low and then low. Okay. Now if you want to put multiple conditions, okay, so I can just put department ID here. Now, because again, now let me just put salary first and then department ID. Okay. Now first the lowest department ID come. Okay. And in that window, your salary is sorted. So basically 20 is the window, right? In 20, I'm getting these two rows. After 20 is put, then we see which salary is small. Then that row comes first and then the next row. Next same goes for, others also. 30 we have one, 40 we have one, so leave. Now 50 we have many, right? So then 50 comes, and then we are seeing only, we are seeing the salary now is sorted in 50. Okay, so basically these are windows, these are small windows which is built. So first window is for department ID. Okay, first department ID is sorted, then for each department ID the salary is sorted. You can add ascending and descending as you wish. So ascending is not needed, you want, you don't want, it's okay. Descending. So now what will happen is for 20, though, because it's ascending, it's still 20. But now, because I did salary as descending, 13,000 came before 6,000. Previously, 6,000 was top. Okay. So this is how you do when you want to sort your data. Okay. One quick thing which I want to show you is column alias. Okay, before moving on to the next thing, I want to show you column alias. Now, this is department ID, right? Okay, with this data, with this query only I'll show you. I want to show it as department, DEPT. So you see, I just wrote DEPT after my department ID is sorted. Same for salary. If you want to show sal, you get just show sal. Okay. Now, if you want to show as sal with S capital, no, it will still come everything in capital. If you really want to show it in this way, like I told you earlier, you remember when I told you single quotes are used for values and double quotes are used for columns and table names. Now is the time we use double quotes. So now you see, it is just the way I've written here. Okay. I can also write space now. Because if I would have done this without double quotes, right, then it will give an error. Okay. Now it is department ID. Because space is not accepted in column name, but we want to show only for the output. So we have given double quotes. Same for table name also. If you want to rename it, you can just put it after the table like this. Okay. And you can call each of the column by using the table name. Okay. It is optional if you want, if you don't want. For salary and department ID, I have not put. For first draft put. So it's optional. It is mandatory when you do joins. When we see how do we do joins. Okay. Then this thing comes mandatory. So now you know how to rename a column. Also, like for example, this comes very handy when you want to show, for example, I want to see the annual salary. Okay, annual salary. So I just do salary into 12 and into annual salary. If this I wouldn't have done, then I would have got salary into 12 as the column header. Okay. Okay. Next, what we will see is the single row functions. Okay. Now we will see some functions in SQL. Now you very well know the basics of SQL. Okay. Next, what we are going to see is the types of SQL functions we have. We have single row, we have multiple row functions. Okay. Now, what is a single row function? It manipulates data items. Okay, so like I said, it's a single row, so it manipulates your data items, the values. It accepts arguments and return one value. Like I said, single row, that means one value at a time. Acts on each row return. Okay, whatever row we are getting, so it acts on each of the rows. Return one result per row. Like I said, for each row return, it will return one result. Can modify data type. You can modify your data type if you want. Can be nested. That means you can put a function inside a function. Okay, that means you can put multiple functions together. Accept arguments, which can be a column or an expression. This means either you can work on a column or you can, have an expression. Like you can just say sum of 20 plus 30, sum of 20 comma 30, so you get 50. Okay. That are SQL functions. Okay, single row functions. Okay, then we'll see what are the type of functions do we have. Okay, so we have character functions, we have number functions, we have date functions, we have conversions, we have general functions, right? So we will see each of them in detail now. First, we will see character functions. Okay, so for character functions, we have the famous case manipulation function. So if you remember, why do we need this case manipulation function? Sometime back I was saying you that SQL is not case sensitive, but the values inside the case sensitive. Now, when we were doing the like query, right? Let me just show you the like query once again. Let me just go to my session. Statements only is fine. See how handy this is coming for me. So that's why I told you that you can always, use this. Okay. So when I had this query, right? Let me just copy this query. So when I ran this query, what happened is it was giving me all the last names where I had A in them. Okay. Now the issue with this is it was not giving me those names which had capital A. Right. Now I want those as well because anyways those are having A in them, right? So ideally I should be getting those. But I don't know which will be capital or which will be small. So what I can do is I can either do upper of last name like A. So when I did this, I get all the last name, whether it had a capital A or a small a. So what this did is it actually changed able, okay, for example, if I'm taking able to completely capital. So now when it was comparing A, B, E, L, everything was capital. And because I am checking with a capital A, so it matched. Same way for bear. For bear, it was BAER, but before matching, every letter was changed to capital and then this was matched and then and that's why this capital A got matched. And why was this changed? Because we put a function over it, upper of last name. Okay, now same thing, we could also have done lower. Now for comparing with lower, it's necessary we put a lower A here. Okay, again we get the same data. So 53 rows selected. Okay, so this is how you can use your functions, okay, to have a better grip on your data. Let me show you how uppercase, lowercase, and init cap works if you actually select the data. How it looks like. Upper, lower of again last name, init cap of last name. So see, for upper of last name, everything was changed to upper, like I told you, right? And then it was compared to upper capital A. So we got a match. Same for lower. We already changed it to lower, and then we put a lower of last name. So each and every letter is changed to lower, and then it is compared. Now, init cap is nothing but where the first letter of the word will be capitalized. Okay, so right now it is capitalized, the first letter of the word is capitalized anyways. But if you have multiple words, do we have something here which has multiple words? Huh. Even though like this administration assistant, right? So here A and A is capital. If this wouldn't have been capital, then, and if you pass this through init cap, then the first letter of each word will be capitalized. That is what init cap is. Okay, next we see, okay, so I just showed you how case manipulation function works. Okay, next what we have are character manipulation functions. Okay, so again these are also very simple. I told you when you were doing the concat with the double bars, right, that we can have a function which is called concat, and we can use double bars also for concat. The limitation for this concat is we can only put two words in it. We can't have more than two words for concat, whereas for double bars we can use as many literals or strings we want for concatenation. Okay, so concat is nothing but it joins values together. Substring, now substring, what it does is extracts a string of determined length. Okay, extracts a string of determined length. So what we had here is hello world. Okay, that was my string. So in substring there are three things which will go in. First is the string, then from which location it will start. One, that means it's the first location, and how many letters we want. So from one we want we want five letters. So HELLO, these are the five letters. So we get hello. So 1 5. So it starts from one and we want the five letters HELLO, hello. So it is nothing but it extracts a string of determined length. Next we have length. Okay, length is nothing but it will give you the length of the string you put. So hello world is 10 letters word, so it gives 10. If you had a space here, it would have been 11. Okay, so it is basically all the characters you have, whether it's a space or whether it's a letter. Okay, so it shows the length of a string as a numeric value, right? Then we have INSTR, which is nothing but in string. Okay, what will this do? This will get the position, the numeric position of the string you say. Now if you say W, then it is first, second, third, fourth, fifth, and sixth. This is the sixth position, right? Hence we get sixth back here. So it will always give you the first occurrence of your character which you are providing. So if W has occurred multiple times, it would give only 6. Now for example, if you have hello world here, right, which is O, Now O occurs twice, right? So 1, 2, 3, 4, 5. So it will return you fifth and not 7, because 7 again O is coming, but it is the second time. So it will only return you for the first time. Finds numeric position of a name character. LPAD. Now what LPAD and RPAD does is it pads or it fills the empty position. Okay. Now for example, you have salary. Now some people earns in 5 letters, some people 5 figures, some people earns in 6 figures. Now if someone is earning in 5 figures, I don't want to show that there's a blank space there. Instead of that, I just want to cover up with a star. Okay, and whenever we have 6 it is fine, but whenever we have 5 or 4, I want to cover up. For here salary is in 10, so whenever we have um 10 it is fine, 10 letters it's fine. But whenever we have a blank space, if it is not 10, then we will have some blank spaces here, then those will be padded with star. So pads the character value right justified, pads the character value left justified. L pattern, R pattern. Next what we have is trim, which is H from hello world. So what trim will do is it will remove the letter H from hello world. Okay, trim will remove the letter H from hello world and it will only give the rest of it. Okay, you can have multiple letters here, so not only H, you can have hello from hello world, so you will only get world. So it trims heading or trailing characters. Okay, so it should be the heading or trailing characters again. Okay, so these are the character manipulation functions. Okay, so now that we have gone through the functions, we will quickly go through how this will be implemented. Let's check on few of the queries, right? So let's see. Right, employee ID. So we will use concat function here, which we learned. We can also use the pipe operator. Then we will use the length operator, where we will get the length of the last name till we get the result. Just think, what did we decide? What did we discuss on in string? What does this gives? Just have a think on that. Okay, so let's go and let's run this. Okay, there's some issue with my session. I need to re-log in just the way we had it earlier. Quickly sign out. So see, we have employee IDs, we have the name. Now because we have concatenated first name and last name, there is no space in middle, right? So both the name are together. If it was better if we could have, put a space in concat, okay? But this will give me an error. Why? Because concat, like I said, can only have 2 arguments. So space we can't put. We have to use double quotes for this. Then we have job ID. Then with the length of the last name. So what is the length of the last name? Which is 4. So king 4. Okay. So coacher this is 7. Okay. Um. Then we have in string, which is okay. So what is A now? What is in string? Like we discussed, in string is nothing but when we want to see if the element is present, and if yes, then at which position. Okay, we want to see at which position the element or whatever we are saying that is present, right? So that is in string. So this is how we can check for the elements. Let's quickly go into this. Okay, this is the same thing. You can try many other functions. So okay, substring. So let's try quickly substring job of ID. This is something important, and this sometimes like we do get. There it was used as a where clause, it's a filter, but we will use as okay, we will use as a column. So we get so a d and underscore. So generally if you have seen the job IDs here, we have the first three as a d and underscore, then we have the ID. So what I have done is I have just taken out the first tree and I am only taking from the fourth position, right? So this is where substring comes from. Substring is used. We only pick out what we want to do. Moving on to the next part. Okay, next what we have is number functions. So what are number functions? When we want to round or truncate or do some other functions with our numbers, okay, then we use number functions. Now round and truncate, they actually does the similar thing. The only difference is for round it will round off data. For example, because 45.926, if I am rounding off it to 2, and because the third number is more than 5, so 2 increases to 3, right? That is how round works. But truncate is just cutting off the last number. Even if it is 6, it doesn't matter. It will just cut off and it will give you the original values only. Okay. Next, what we have is mod. Now, what is mod? Mod is nothing but modulus. Okay. What does modulus mean? When we divide, okay, we get a quotient and remainder, right? So modulus will return the remainder of your division. So 1600 by 3. So 300 into 5 is 1500 and the balance is 100. So that balance is written by mod function. Okay. Okay. Let's see what is a dual table is. Okay. Select sysdate from dual. Okay, first let me show you what this dual table contains. So dual table is nothing but a dummy table which has no value. It has a dummy value which is x, and you can try out many functions in this dual table. For example, you want to try out a function but you don't have a proper data for that. So you can hard code the data in a function and you can run it using a dual table. This is a very good feature in SQL, which or specifically to be said in Oracle SQL, which many other database lacks. So this is a very good thing. You can try out the functions using the dual table. Okay, so right now what we will do is we will try out the round function. Okay, so let's try round, round because we don't have proper data on which we can try round, so we are using the dual table. So 40, so 100.987, okay, comma 2. For same data, we will use trunk, okay, and mod is easy. Mod is nothing. 1000 divided by 3, okay, okay. So round of this is 100.99. So 7 increased 8's value to 9. Here 987 because it's a truncate, so the 7 gets removed. Okay, and then mod. So 1000 divided by 3 is 999. the balance is 1. So that is what we are getting here. So mod is like very useful when we want to check if the value is even or odd, right? That is when we can use mod. Okay, moving ahead. Conversion functions. Okay, now we have data types. Okay, so we have quite a few kinds of data types in SQL. We have number, we have varchar, we have date, right? We have binary. So we have quite a few kinds of data types. But in basic, we have number, date, and character. These are the main 3 types of data that we have. You have many others, definitely. You have JSON, you have binary data, right? And you have many things else. Okay, but these are the basic 3 types of data types we have. Now, sometimes what happens is, let me show you the data so you will gauge what I'm trying to say. Okay, so I have my employee ID, right? Now, employee ID is nothing but the ID of the employee. Now, and this is a kind of a ID, right? So if we say 130, so we'll know that okay, it's for Atkinson. If we say 132, we'll know okay, it's for Olson, right? Now, can we do any mathematical calculations with this? No, right? Like we can do, but logically it is incorrect because employee ID you shouldn't be doing with any identifier, any column which is identifier, you should not be doing any mathematical calculations, right? That is wrong. So to avoid that, what we can do is because this has numbers, the employee IDs are in number form. So by nature, this will be a numerical column. But what we can do is while creating itself, while the table is being created, what we can already do is we can put this data in a string format, okay, like a varchar. So what happens is then we won't be able to do any manipulations with it. Okay, now just imagine we have this column called commission percent, and some people get commission, some people doesn't get commission. Okay, now this when it was created as a string or a varchar that we just need to store the commission. Okay, and a varchar column can store number, right? A varchar column can store number, it can store dates, but a number column can't store varchar. It can only store number, right? That is a point. That is a logic here. Now, because this was stored in string, okay. Now, if you want to do some calculations with this number, the commission percent, like if you want to multiply the salary with the percentage, what we need to do is we need to first change it into numerical format so that both my column, because salary is already in numerical format and a commission percent which was earlier in string, now we should convert it into integer and then we should multiply, right? If we need a function to explicitly change this value to number, that is called an explicit conversion. Okay, but even though this column is stored in a string format, but for multiplying I don't need to explicitly put it into a function to change it to a numerical column, then that is called an implicit conversion. Okay, the conversion of a column from one data type to another data type is called typecasting. Okay, the conversion of a data or a column from one type to another type is called typecasting. Okay, now see this diagram. So now you know that we have 2 types, implicit and explicit. Okay, now if something is in the character data type, okay, and we want to change it to number, okay, or to date, okay, we can do that, but then that is an explicit typecasting. But if I want to change from number to character and to date or a date to a character, which is very easy, this is called implicit typecasting. Okay, so when you want to change anything to a character, number or date, you can call it to char. Obviously you don't want to change a number to a date, that cannot be possible, so hence it's not shown. Now, if you want the character to be transformed to a number, then you need to use the function toNumber. And if you want to change it to a date, you need to use the function toDate. Okay, so these are the basic functions that we have for conversions. Okay, now moving ahead. Let me show you some examples actually. Select last name to char date, comma f it mon th y. Okay, okay. So what we saw is we just converted a date to a particular format. So if you see, it was in this format, right? 17 June 03. This is the format which I told you earlier, right? This is a default date format, DDMONRR. Now what I did is I changed it to a format of 17 June 2003. Okay. So how did I, sorry, how did I do this? I changed it to a character variable. Okay, to char. The first argument is the column. Okay, and the second argument is the format. Okay, so this is nothing but how we write a format. We started with FM. Okay, we started with FM and then we write DD. So DD comes directly here. So this DD and this DD is same. Then instead of a hyphen, we have a space here. Then we have month. So instead of MON, we are having month, complete month. Hence we have the complete month here. And then 03, which is 2003, which is a year. Which is nothing but the hire date from employees. Okay, this is how we can change the dates. Next, I'll show you another function, not another function, but how we can format number. Right now we formatted a date, right? Let me show you how do we format a number. Salary, and then we put it in dollar 99, comma 999. Okay, this is the original salary which we had in our column as data. Okay, and this is the salary which we are showing. What are we showing? We are formatting it. So we want dollar sign to come in the beginning. Okay, then we want the first two letters. Okay, or, from the right hand side, the the fourth and the fifth letter should be here. After that, we should have a comma, and rest all should come after it. And also we should have a decimal place, even though if it's 0, but we still should have a decimal place. Okay, so this is how we can modify a number also. Okay. So we'll move ahead now. Nesting of functions. Okay. So just now we learned how single row functions work, and now we will see how we can nest the functions. Nesting of functions means a function which can insert another function. Okay, now how does that happen? So let me show this to you. We have, before going into nesting of functions, we have something called as NVL. Let me show that to you, and then it will be much clearer. Okay. We have functions for null. Okay. Some functions which we can use for null, which is NVL, NVL2, nullif, coalesce. Remember, these functions differ from language to language. So MySQL and Oracle and TSQL, they have slightly different functions for this. So whenever you are working with a new database, just Google out, okay, the function. Okay, just Google the function, that what is the corresponding function for NVL in MySQL. Okay, I always suggest my students to Google out things, because Googling out is very important. This is a very important skill everyone must possess to be successful, for sure. So do that. Okay, let's go to the functions now one by one. The first function is NVL, and NVL can take two arguments. What it does? So first is NVL, so it will convert a null value to an actual value. Now, what it will do is it will first see expression 1. Okay, if expression 1 is not null, okay, so what it will do is, if expression 1 is not null, then it will give that. Otherwise, it will give the second expression, expression 2. Understood? So if expression 1 is not null, it will print expression 1, or it will print expression 2. Now, next we have NVL2, which will say if expression 1, so it will take three inputs or three arguments. So expression 1 will be checked. If expression 1 is not null, then expression 2 is returned or printed. But if expression 1 is null, then expression 3 is printed. So it is like a check. NVL2 is like a check. If this is null, then this is printed. If this is not null, sorry, if this is not null, then this is printed. If it's null, then this is printed. Okay, then we have nullif. Okay, now what is nullif? We have two expressions here also. So it compares the two expressions and returns the null if they're equal. Sorry, yeah, so it will check the two expressions. If they are equal, it will return null. If they are not equal, it will return the expression 1, the first expression. Okay, and then we have coalesce. Coalesce can have n number of inputs: expression 1, expression 2, expression 3, expression 4, any number of expressions. Okay, so it will return the first not null expression in the list. Now if we are putting three expressions, expression 1, 2 and 3, now if one is not null, it will return expression 1, it will come out of the function. But if expression 1 is null, it will check if expression 2 is null or not. If expression 2 is also null, it will check for expression 3. So like this, it will keep on checking until it meets the first not null value, and that will be returned. Okay, That is what coalesce is. Okay, so NVL converts a null to an actual value. Data types can be used are date, character, number. So date, character, number types of data only can be used for this. Okay, data types must match. Okay, so data types must match because you should give the similar data type here. You can't give a date and a character or a number or a character. Okay, you should give the similar data type. Okay, so what we are doing is select. So this is one example. Let's directly try it out and we'll see. Select last name, salary, NVL of commission percent, commission percent, comma 0. Okay, then salary. Okay, let's put it in a bracket. Salary into 12 plus salary into 12 into NVL of commission percentage, comma 0. Okay, and then we close the bracket. Okay, let's try it. So, and let's see what happens. Okay, so what we see here is we have last name, we have the salary. Next, what we are taking is NVL. Okay, so what does NVL means here? We have commission percent. Okay, if this commission percent is null, replace it with 0. Okay, if the commission percent is null, replace it with 0. And next, what we are doing is we are taking the 12-month salary and we are calculating the commission that person will get. Okay, so if you see, even though someone has a null, we are still getting the salary. Okay, now just quickly let's try this out without using NVL here. Okay, so just multiply 12 into commission. And what would have happened if that was the case? Okay, and okay. So see, what happens is for all of them where we didn't have a commission, right? We are not getting the annual salary. See, if someone is not getting a commission percentage, that person will still get the salary at least, right? The commission part he is not getting, but salary he should get. But somehow for this calculation, even though this and this is almost same, we are still not getting the annual salary. The reason is whenever you are doing any arithmetic calculation with a null value, your result will always be null. Okay, whenever you are doing any calculation with the null value, the result will always be null. Hence, if you see here, what we are doing here is salary into 12. We are adding this to salary into 12 into commission percent. Now, for all those where the commission percentage is null, we are not doing nothing but we are multiplying salary and 12 with a null. So we are getting null here in return, and this null added to this value is also null, and hence we are getting a null value. This is the reason why we need to use NVL to suppress the null with a 0 And so even if there is no commission, right, so this part will eventually result to 0, and salary into 12 plus 0 is nothing but salary into 12, right? 0 plus any number is the number itself. Hence this is important, is hence, and using annual is important. Okay, next what we will see is how to use a annual 2. Okay, so let's select this, select last name, salary, commission percent. Okay, fine, till here it is fine. Next, NVL2, commission percent. Okay, sal plus com was sal. Okay, so what we are doing here is we are checking if the commission percentage is null. Okay, then we only get the sal. So basically if it is not null, salary plus commission is what the person will get. But if commission percentage is null, the person will only get a salary, right? So now if you see, for the person where we have a commission percentage, if you see this, there we have sal plus com, which is salary plus commission. But for the ones where we don't have any commission, there we only have salary. Okay, I hope this part is clear. Moving into null if. No, null if was used when we wanted to check if both the arguments we are giving is same. If both of them are same, then we get null. If both of them are not same, then we get the first expression, whatever we are putting as the first argument. Let's try this out. Okay, so what we are doing here is we are first taking the first name and last name, which is normal select. Then we are taking the length of each of the column values. So here ln, so it is 5. Here it is abel, so it is 4. Here it is sundar, so it is 6. Then and so it is 4, right? So we are taking the length of the first and last image. Now for the columns where it doesn't match, we will be getting the length of the first name, because that is what we've put as the first expression. Our first expression is the first name, the length of the first name to be more specific. Now you see for John Chen, right? We have 4 and 4. Okay. So both first name and last name, the lengths are same, and hence we get a null value here. Why? That is what null if is, right? We get a null value if both the arguments we have put in the null is same. Okay. If both of them are same, then we get a null value. Otherwise, we get the first value. Okay. I hope this is clear. Moving ahead. Next, we will see some conditional expressions. Okay. With the code. Okay. we didn't do the coalesce function. Okay, so let's do the coalesce function first and then we'll move ahead. Okay, so like I described already, coalesce function, we'll see how we can implement it. Coalesce. Okay, so commission percent comma salary comma 10. Okay, so what this will do is this will give me the null first not null value. So if you see for king, that means even take these as well, so you will understand. Salary. So see, in our call list, the order is first order is commission person and then it is salary. And then it is 10. So if you see for all these where we have commission percentage is null, so after it identifies a null or encounters a null in the first position, it goes to salary. And as we have seen on data, right, salary is generally it's a not null column. So we are getting the value here, not the not null value, right? That's what we are getting here. Now, if we go down where we have the commission percentage, right? There, commission percentage is actually being written for coalesce. Okay. So whichever is the first not null value for that particular row we get, we return that using coalesce. Now, in this condition, in the query which I have written, there will be no such scope to get 10 because we have seen the data. Every row has a salary. It's not that there is a row which doesn't have a salary, right? Every row has a salary. Okay, so so we won't get a 10, but it's always good to have a default value at the end so that in case everything goes to null, then there is some value to hold. Either if you can put 0 as well. Okay, so it looks good. Next, now let's move to conditional expression. Okay, now what is a conditional expression? We generally, if we know some other programming languages, we generally have if then else logic, right? Even if we don't know, it's fine, we'll see how the conditional expression works. So basically conditional expression is nothing but you will perform certain action only if a certain condition is met. What is a conditional expression? You will perform certain action only if a certain condition is met. For example, for example, it is a rainy season which is going on. Okay, but I have to go to school tomorrow. Now, if I would have been a child, I would have thought it should rain heavy, right? And then I don't have to go to school tomorrow, right? Now, this is a condition which I am thinking that if it rains, I will not go to school. But if it doesn't, then I have to go to school, right? That is what conditional expression is. If the condition is satisfied, then we perform certain task. If it is not satisfied, we perform some other set of task. That is what conditional expression is. Okay, we have two types of conditional expressions in SQL. One is case and one is a decode. Okay, now we will see in detail what each of them indicates. Let's write a query for this. Select last name, job ID. Okay, salary case job ID when IT prog then 1.10 into salary when S clerk then 1.15 into salary when SA rep then 1.20 into salary. Okay, else salary and as revised salary. Okay, okay, where did I put double Y? Okay, here first. Okay, so what I did just now is I am going in a loop for each of the row. So I go to the first row, I check the job ID. So that's what I'm writing. Case is job ID. If this matches to IT program, sorry, this should be IT program. Okay, if this matches to IT program, then I should multiply salary with 1.1. Okay, if this is ST clerk, I should increase by 1.15, which is SA rep, then 1.2. If not, if any of the match doesn't happen, then just put the salary and then end as the revised salary. So basically, only for the 3 job IDs, my salary is getting revised. Okay, only for these 3 job IDs. Okay, so you see here for ad press, it doesn't come, so we are just getting the equal salary. Same for ad VP and same. Okay. Now IT prog. Okay. Now see IT prog we are increasing it by 1.1. So 9,000 and the revised salary is 9,900. For all the IT prog is increased. Okay. Then what do we have? We have ST clerk and SA rep. So let's see. ST clerk. See for this. For 3200, it's 3680 now because it's revised with 1.15% of the salary. Okay, so this is how we can use case. So basically we have the column on which we want to put the case and then we put the values for it. So when either of the values we put here matches to the job ID of that row, then we perform the action we want to do. If nothing matches, then we can have the else statement. Okay, then we have the end statement ending it, and we can put a column name as or the alias of the column. Okay, so this is how you can write a case statement. Okay, so this is another way you can write your case statement where you equate in each of the when statement. Now, if you have a single variable on which you want to match and you have a very simple case statement, you should go for the first approach which I showed you. But sometimes, and generally this happens when you're actually working, right? You will have multiple such things to match for a particular row. When you have such cases, you need to write the matching condition for each when in that line itself. So then you need to use this approach where you write the matching condition in each particular line. Remember, else is optional, so else is not needed. If you want, you can skip else as well. Okay. So these are the two ways in which you can write the case statement. Okay. Next, what we will see is the decode function. Okay. Now, decode function is also kind of case statement. Let me show this to you, then you will understand where it differs. Mainly, if I tell you, decode statement is very much like the first approach of case statement, where we had case job ID when IT program then 1.1 into salary, right? So that is the approach which is exactly similar to a decode statement. Let me write the program, then I'll explain to you. Okay. Okay, I couldn't see the bracket which I had put. Okay, so what we see here is job ID we write once. So this is the column on which we need to do our matching. Okay, so or the comparison. So what we are saying is in his job ID, if it is IT program, then it's 1.1 under salary. If ST clerk, then 1.15. If SA rep, then 1.20. All this put salary, right? Now, this is very similar to the first approach of case statement where we only had to match with one value. So if it is one value, obviously instead of going for a case statement, definitely you should go for decode. But if it is not the case, on that case, and we have multiple matchings to make or multiple comparisons to make, then this is then you can't use decode or the first way of doing. You have to use the second way how I showed you, where we have to do the comparison in each of the when lines. Okay, moving ahead. Okay, now we come into a very interesting part of our SQL journey, which is the joins. Now this is interesting as well as this is important as well, and there is no, I think, interview which doesn't have join questions, right? So we are going to now learn joins. Okay, so first what we see is a Cartesian product. Okay, what is a Cartesian product? It is nothing but a join. So what is a join? First of all, join is when we join two tables, okay, together to get a value. So like I gave you an example, right? Let me just show this to you. So this is an employees table, right? This has many columns and it has job ID as well, right? So it has department higher the job ID here, this one. Now we have another table which gives more information on each of the job ID, right? So it says what is the job title, what is the min salary, what is the max salary, right? So it gives me more information or it throws more light on each of the job IDs. Okay, so now if I want to get the data, so if I want to get the job title also here, what I can do is I can do a lookup. Okay, I can match this job ID and I can find it here. Okay, that was ST clerk, and ST clerk is nothing but stock clerk. Okay, so I tell it, okay, this is a stock clerk. Then I say, okay, next is SM man. So SM man, we have to go and search here. SM man, which is sales manager, this one, sales manager, right? So like this, we can do a lookup. Okay. The same thing we can do very quickly and very easily in SQL is using joins. Okay. So let's see the different ways of joining. First, like we said, is a Cartesian product. Now, what is a Cartesian product? It is formed when a joint condition is omitted, or a joint condition is invalid, or all rows in the first table are joined to all rows in the second table. Okay. So to avoid a Cartesian product, always include a valid joint condition in a where class. Okay. So what is a Cartesian product? If you see in the employees table, we have 20 rows, and department tables, we have 8 rows. Now a Cartesian product is nothing but 20 into 8 rows, which is 160 rows. And what does this mean? Each row of employee is joined to each row of department. So it will, so if we do a Cartesian product, then King works in administration, King works in marketing, King works in shipping, King works in contracting. Same way Kochar also works in administration, marketing, shipping, contracting. So basically it what it says is the story which is formed is each of the employee works in each of the department. It is wrong, right? But this is called Cartesian product. Okay. Now, this is also sometimes needed. There will be some cases, though it is a very rare case, but there are cases where we have to do a Cartesian product. Okay. Now, let's see how do we put a joint conditions. Now, this is Oracle joins. Okay. Where we just put the select. So if you see, we have the table 1 dot column, table 2 dot column, from table 1 comma table 2, where table 1 dot column 1 is equal to table 2 dot column 2. So this is nothing in where we are putting the matching condition. Okay, that means if the values of the column matches, then you join them. Write the join condition in the where clause. The join condition is in the where clause. Prefix the column name with the table name when the column name appears, when the same column name appears in more than one table. Now, what does this means? Whenever you are joining and you have the same column name in both the tables, you need to tell from which table you are referring this column. Okay, so for example, if this is a column, okay, and this is same in both the tables, table 1 and table 2, so we need to write table 1 dot column and table 2 dot column to indicate that this column is coming from table 1 and this column is coming from table 2, even though the column names are same, right? And this also is applicable if you are doing this join in this column where it is same. Right now, if column 1 and column 2 the names are different, it is not necessary that you need to put the table name before the column name, but it is always advisable that you should do that, so that your code is very clear and very neat and people can just look at the query and they understand that, okay, this column was taken from this table. Okay, this is very important. Okay, so now next what we'll see is an Equijoin. Okay, what is an Equijoin? You see this employees table is has a department ID and the department table has a department ID. Now we have a foreign key and a primary key relation. Let me quickly describe what is a foreign key and what is a primary key, right? So foreign key, so a primary key is nothing but a key which uniquely identifies the rows in the table. Okay. Also, a primary key should be unique. Like I tell, you can't repeat primary keys, and there can't be any null in a primary key column. Okay, there can't be any null. Whereas in foreign key, the values can repeat, right? The values can repeat, it can have null. Okay, but the only condition here is this value should be a subset of the primary key. Foreign key should always be a subset of the primary key. That is, the range of this value should be actually already present in departments. If I am putting a department ID which is not already present in departments, employees will throw an error that, see, you are trying to insert a record and a department ID which is in which the department ID is actually not present itself in the main table of departments. It will throw me an error. Okay, so how do we put this? Let's write the query. Select emp dot employee id emp dot last name emp dot department id. Okay, department id. Then we have dept dot department id and dept. Okay, just remove this. Dept dot department name from employees, HR employees, and let me select HR departments also now. Departments, and let me name them. So HR employees can have the name of EMP. Okay, HR departments can have a name of DEPT. Okay, where EMP dot department ID is equal to DEPT dot department ID. Okay, so what we are doing now is we have joined both the tables on the department ID. Okay, so what we are getting here is now the department name for each of the departments. If we want, we can also skip one of the departments here, not needed, because obviously if they're same only, then it comes. What happened to this? Okay. Okay, now this makes more sense. Okay, so this was about Equijoin, where only if the values are equal, then we get the row. Then the row is written. Now, along with this, what we can also do is we can have additional join conditions using the AND keyword. Okay, now we have already learned how to use AND keyword. So what I can do is I can put AND last name is equal to okay. So I get for Matos, I get the department name and whatever data I need. Okay, so this is how you can use Now, if you want to have other tables, okay, if you want to have the location also, because department ID, if you see, departments has department name, which we just now got. It has location ID as well. Now location ID, you won't get an employees table, so you can't join employees to location directly, but you need the departments table to join. So we have already joined departments table. What we now need is to join the locations table, and we get the location as well. So let's pull first locations loc dot city, and here add HR dot locations, where employee department, and DEPT dot location ID is equal to LOC dot location ID. What happened to this? I think this should be correct, right? Look, see it, okay, I didn't put the name of LOC. Okay, now it works. So see, whenever there is a location ID match, that is when we get the city also. Okay, so now we are getting the employee details, the department details, and the city details in a single output. So this is the magic of joins, where even though our data is distributed across multiple tables, that is how tables are in RDBMS, and the all the major databases right now are based on RDBMS, right? And what we do, even if it's not based on RDBMS, when we are finally querying it, our interface at least is made in such a way that we think that our data is in RDBMS format. Okay, because nowadays databases are very advanced. Databases are stored in various formats, right? The text file format, NoSQL format, and there are many other formats. But at least when we query, we get this view of an RDBMS view. Okay, so coming to the point where we were, so locations we pulled, this is a new table which we pulled, and we made a join on a department and a location. So it's now employee joins to department and department joins to location. So this way we can join employee and the location as well, because department ID was the common bridge. Okay, and from location table we picked up city. So this is how we can get data from multiple uh, tables together. Okay, moving ahead. So next what we see is the non-equi join. Okay, now what is a non-equi join? Sometimes what happens is we don't want to have a direct join. Okay, so we don't want a salary to have a direct join our salary, but we want what we want is that it should be somewhere in the middle of it. So if a salary which is for example 4,200, right? So it falls between 3,000 and 5,999, right? So I want the grade to be shown as B. Okay, so if I want this kind of a join, this is called a non-equi join. Okay, so how can we do this? Do we have, okay, so we have a job ID here, and we have the minimum salary and maximum salary. What we can do is we can write a non-equi join on this. Let's try this out. Select the employee ID and this jobs table, job. We don't need one more. Okay, and let's get the job title based on not the, we will not now join on job ID, we will join on minimum salary and maximum salary. So let's get the job title, job title. Okay, from HR jobs where emp dot salary between job dot min salary and job dot max salary. Okay, let me even pull out the salary also, so it will be easier. So let's have emp dot salary, what we picked from employee, and from job we pick job dot min salary. Job dot max salary. Okay, now let's see. Okay, so you see this salary from which we are picking from employee, this is between this salary, right? Then 2200, this is between this 2008 and 5000. Let's go for some other salary. Okay, this one 2600, it is between 2500 and 5500, right? So this is how we can get, we can join between two columns. So this is not an equal join, but then it is between the range, right? So hence we call it as a non-equi join. Okay, then we'll see next what we have is outer joins. Now outer joins, so there are different kinds of joins, right? So we learned equijoin, non-equijoin. Now outer joins, we have a left outer join and a right outer join. Earlier we used to write it in this manner. Let me just show it to you really quick. Okay, so if in case this was our tables, right, and I wanted all the columns from my employee table, because this is employee, right, and this is department. So I want all the rows from my employee table to come in, and only if there's a corresponding match in department table, then only get me that value, otherwise don't get me the value. That means if we are doing an equal join, if this value is present in both the tables, then only we get the row, right? If that value is not, if a value is not present in either of the table, we won't get the value. That is what equijoin is. But in outer joins, if the value is present in one of the tables which we are specifying, then we can get the value. If it is not present in the others, still it's fine. Okay, so if we put a plus here, okay, now it becomes a left join, which means all the rows from this table, that is the employee table, should come, and the corresponding matching rows from department should come. If there is something which is extra in employee table and it is not present in department table, it is still fine, but then that should come in. Now again, I should remind you that this is an old way of writing. Okay, this is an old way of writing of joins. Very soon, like in some time, we are going to learn how to write the joins properly. So this is the syntax which we will be learning in some time. Before that, there is a very important concept which we generally get at work and we generally get at interviews. This is a question itself which is generally we get. Okay, so it's a very important one. Understand this self join. Now let's go to our data. Okay, if you see, for each row we have the employees, right? We also have a manager ID. What is a manager ID? A manager ID is nothing but the employee ID of another employee, right? And that employee is the manager of another employee. For example, if we go for this 130 employee, which is Atkinson, so Atkinson's manager ID is 121. Now if I go to 121, I see that 121 is Adam Fripp. So Fripp is the manager of Atkinson, right? Right. How do I get the name of the employee and the name of the manager in a single row? How do I do that? Because we don't have another table as such, right? Where we have the manager ID and the manager name, right? We don't have it. Everything is in the same table. So how do we do that now? So that is when self joins are used. Okay, that is when self joins are used. Let me show you how we can do it. Select worker dot last name works for okay. So now HR employees, one of them will be worker. Let me write the query and then I'll explain you how this is working. Okay, so now what we have, bait works for Cambridge. Let's check if that's true or not. Okay, let's see where is Bates. Okay, Bates, and we have Cambridge. Let's check them out together. Okay, Bates work for Cambridge is true. Elizabeth, 148. Right, 148 is none but than Cambridge, right? So we are getting the correct data. Now, how did this work? What we actually did is we took the same table and we joined it with itself only. Okay, because data is in the same table, right? Data, the manager data is also in the same table. So we took the two tables and we joined them together. Now, because how I checked this now, I went to the I went to the employee, I picked up its manager ID, right? So for the worker, I picked up the manager ID. That's what I'm doing here. For the worker, I'm picking up the manager ID, and then I am searching for this ID. Okay, once I got it in the table, I search for its last name. So for the manager, I search for the employee ID. And this is how I do a self join. This topic is a bit confusing, I understand. So if there is a difficulty for you to understand it in the first place, try executing this query and try and repeat the recording again so that you understand exactly how this is working. Okay, so this is how self join works. Now let's come to how actually joins are written nowadays. So whatever, writing with a comma and writing a plus sign, these are old school writing of queries. And right now also sometimes you will get, so if you go to big organizations which had queries written from many years, you will get such queries where you have plus written to indicate a left join or right join. But nowadays everyone uses this syntax. Okay, so let's see. So cross join, the one you see, cross join is nothing but a Cartesian product. Natural join is nothing but an equijoin. Okay, same join, the natural join or an equijoin, we can do using the using column. Same thing we can do by specifying the column names. Okay, then we have the left, right join or full outer join. Okay, this is the one which we did with plus. Okay, now we will see each of them how we can write the queries. Okay, so let's see. Cross join, as you know, it is nothing but a Cartesian product. Okay, so let's do this. Remember, when in this syntax, which is the latest syntax, we don't write the join conditions in where. Okay, we write it differently, so I'll show you that. So let me do a cross join now. Cross join of last name and department name. Okay, now we get many. Okay, now we get many rows. So basically what we are doing is, if you see here, Abel works in administration, Ander works in administration, Atkinson works in administration. Like this, we will have 108 rows where the department name will be administration. So basically, each row of employee table is being joined to each row of department. And that's the reason why we don't need a common column here, because we're not joining on any column, right? It's just a cross join. So see, once administration gets over in 108th row, in 109th row, we have Abel again going for marketing and Andy again going for marketing, Atkinson going for marketing, whether we already had this for administration, right? So basically each row from the last name is multiplied to each row to the departments table. Okay, this is what cross joins is. Okay, rarely used, but sometimes yes, it is used. Okay, next we'll see on natural joins. Okay, now what is a natural join? When you have the same column name in both the tables, you don't need to specify the column name upfront. Okay, that is what a natural join is, because the join is very naturally. Okay, let's see. Okay, so the department ID column is same across employees and departments, so we don't need to put any um, common any column, right? That's the natural join. Remember one thing, when you are doing a natural join, the column name should be same and the column data type also should be same. It shouldn't be that, okay, even the name is same and we know that both of them indicate the same thing, but the data type for some reason, in one it was numerical and in another it was uh, string, right? That shouldn't be the case. Okay, so this is what natural join is. Next we will see joins using the using clause. Okay, using clause. Now here what we will do is we will specify on which column to join. So we'll just remove this join. Okay, this is also kind of an equijoin, and the previous one also was equijoin. Okay, using department ID. Okay, so using department again is the same. Now we are specifying that okay, this is the column on which you need to make the join. Okay, this is nothing but your use natural join with the keyword using. Okay, okay. Next what we will see is use is with the on clause. Now on, so let me just name it. It will be mpm, it will be the ept. So emp dot department id is equal to dept dot department id. Okay, again the same result. Basically both are same, but there we were using clause, here it is on clause, and again this is the equijoin, where only if the value is present in both the tables we get the data. Now we move on to the interesting left join and right join. Okay, we will see that. So previously what we saw is whether in whichever side we write a plus, that is the join which we're doing. If we are in left, it's a left join. If it's a right, it's a right join. Now we will specify left join. Okay, now when you specify left join, everything from department ID will come, but only the corresponding matching from the department table will come. Okay, this is actually, if you see logically, this doesn't make sense. Just think why. Pause and think why this doesn't make sense. Now, department ID, the primary key of department ID lies in department table, right? This table. And in employee, the foreign key lies, right? Now, how can that this be a case that we have a department ID in the employee table which is not present in department table, right? It can be the other way around. So if I would have written department on this side and employee on this side, then it might be the case there are department IDs where there are no employees working, and that would have come up in this result, right? So writing in this way, it won't make sense, but yeah, syntactically and everything is it is correct. That is a reason why you should do what you should do is just the way I have done. I have taken a dump in the Excel, okay, of all the data of the tables that I'm going to use, okay, and so these are the tables which I'm going to use and data. And whenever I am writing a query and I know, okay, this is the question, I can just, go here and I can take the question, think about the question, filter out data in Excel and see what all rows I am getting. And then I see if I'm getting the correct rows and the correct number of rows here or not. Okay. You can do this. Okay. So right now we just run left join, right join. Okay. 106 rows. Now right join. Now 122 rows. Why? This will make sense because there are some departments, see, there are these departments where there no one is working. But because we did a left join there, so obviously this being the foreign key, this is as a subset of this. This is the superset. So because we did right join, so everything from my right table is coming and only the corresponding matches from the left tables are coming, right? This is what the difference between the right join and the left join is. Okay. So another thing is three-way or multiple joins. Now, right now we saw joining two tables. Same way you can join multiple tables. So how do you do? You can do whatever, inner join, left join, right join, hr dot locations on hr, okay, hr, okay, locations is LOSE. So DEPT dot location ID is equal to dot location ID. Okay, we didn't pull anything from here. Let's pull something. Okay. So we still get 120 rows. Okay. Because now this every department is there in every city. So hence we are getting, even after doing an Equijoin, we are getting all the rows now. Okay, so we joined three tables here. Like this you can do as many tables as you want in queries in workspace, in workplace. You have joins with 10-12 tables, okay, because data is at a very normalized form, so you have data at, in a scattered way or a distributed way, to put it more properly, in distributed way. You can also put conditions, okay, so you can put where filters, you can put or filters. So here you can put and then you can just put in the manager ID, for example emp dot manager ID is equal to, okay, like this you can see. Okay, let's move ahead now. We will see how can we aggregate data using group functions. Okay, now what are group functions? So we learned a single row query, multiple row query, right? The single row query we are already done, where we used to get a single row, we used to do some function on the row and give an output which is also single row output. Now these are multi-row output, where what we do is we aggregate the data, okay, and then we try to produce a single output, okay. So these are group functions. The group functions operate on sets of rows to give one result per group, okay. So we group our data in the, like whichever whatever group we want, and then after grouping we can do some or make some analysis on data, or make some or give some output. So for example, you can do a sum, you can do an average, okay, many things you can do. Let's see what are the things we have. We have average, count, max, min, standard deviation, sum, variance. We can do many things here, okay. So how do we write group functions? So normal select and then the column, okay. Then we can have multiple columns here. Then group function. Okay, and also this column is optional. So if you want do a group function on all the rows, you can just exclude this column. Okay, otherwise this column creates a window. Okay, then group function on some other column from a table where you can have a where condition if you want. Group by mandatory again if you have a group function. So this column will come here, and order by the column that you want to order by. Okay. Let's see. Creating groups of data. If you see here, employees. So if I do a group by department ID, what's happening actually is this is the data, right? So for the 10 department, I only have one person, right? So 4400 is what comes here. Now for 20, if you see, I have two departments. So 1300, 13,000 and 6,000. Now the average of these two is 9500. Now this is what we are getting here. Okay, next for 50. Okay, so 50 I have some 5 rows. So the average of these 5 rows is 3500, and that is what we get there. So this is how we do the group functions by a particular column. So in this case it is department ID, and we group the data based on a particular column and perform the function on the column on which is a numerical column. Also we can do a grouping by based on more than one column. So previously we only did for department ID. What we can also do is in each department ID there can be multiple job IDs, right? If you see for 50, earlier we had 550s, right? Now also we have 5, but then now four of the 5 rows for department ID 50 is ST clerk, whereas one of them is ST man. Now what happens is if you do a group by of department ID and job ID where department ID come first, so you will have it this way. So 50 for ST clerk, and when it's 50 for ST clerk, this rows gets summed, and then you get the data 50 row for ST clerk 11700, and 50 of ST man. 50 of ST man, again it is same. So it is only one. So because so it will be same. So 5000. Right? Let's see how can we write these queries. Okay. So salary is a column in which we can do whatever we want. Average of salary, sum of salary. So here we are not putting any grouping columns. We just want in the overall data what is the min, what is the max to understand the data, right? We do this kind of checks generally when we get new data. So you see average of salary 6461. Okay. What do we do if we don't want all this? We can round off it if you remember. So nesting of functions, you remember we learned nesting of functions. So I write average of salary in between round, and it's okay. I just put for 2. Okay. Now this looks good, right? Then we have sum of salary. Then that means total salary being spent on my employees is this much. The minimum salary someone is getting is 2100, where the maximum salary someone is getting is 24,000, right? Now let's see the one which we were getting there. department ID, comma sum of salary. Okay, group by department ID. Okay, so what I did is I grouped by department ID. So for 50 total salary is this much, 40 is this much. Now if I have job ID, also I can just include department ID, comma job ID. Remember, this is mandatory. Okay, whatever you're not grouping, that column should come here. Okay. Okay, next thing. What if we want to put a filter condition on my grouped function? For example, in sum of salary, I only want those departments where the sum of the salary is greater than 10,000. Okay, so what I do, group by, then having sum of salary greater than 10,000. Remember, whenever you're doing a group by, you can't use a where clause. See, you can use a where clause. For example, here, where department ID is equal to maybe or maybe department ID is equal to maybe what, 50, say 50. Okay, you can do this thing. Okay, you can do this kind of where clause. So group by will come then after where clause, but you can't put this kind of filters, okay, in where clause, because this is a new new column itself, which is new, or a new expression which is being built here. So that goes into having. Okay, so having sum of salary greater than 10,000. Okay, always remember this. And then if you want, you can order. Okay, order your data, order by job ID. So if you remember, we had discussed that order by always comes as the last clause of a query. Just put it for descending. Okay, now we see. Okay, so we learned how can we do grouping. Okay, you can try this. You can try the same thing using various other grouping functions on your own. What you can also do is you can nest. Okay, your queries. Okay, you can also do that. Now let's see some other things in grouping. Okay, you remember we did a count. Okay, so there is something called as count in SQL. So let's have a count of department ID. Is it correct? Okay, 106, which means there are 106 rows in my employees table. If I would have done this in any other column, I would have got the same data. Let's see what I would have got if I did on a null column, where I get 30 or 35, which means there are 35 rows in the table which in which the completion percentage has got some value, right? Now let's go back to the previous one, department ID. So we got this as 106, right? But actually this is not correct, right? Because department ID, it's repeated. Now what I do is, in case I put distinct here, I get 11, which means there are 11 distinct values of department ID in my column department ID of HR.employees. Okay. Okay. Moving ahead. Subqueries. Now, this is also a very interesting concept. So, using a subquery to solve a problem. Who has a salary greater than able? So for example, I know what is able salary and I want to find who has salary greater than able. One way is, first I find out with a query that, okay, select salary from employee where last name is equal to able, right? We can do that. But why? And then we get the salary and then we hard code. So select star from employees where salary is greater than the salary we just now got. We can hard code the salary, but that is not how it should be, because able salary can change over time, right? So for that, we need to use a subquery. Let's see the syntax first. Okay, the subquery or the inner query executes once before the main query, right? The result of the subquery is used by the main query. Okay, this is the subquery. It is used by the main query. Okay, so select list from table where the expression, this is the operator which is equal to or in or greater than or less than. Okay, and then we have a list. So first this executes. Okay, first this is executes and then we get it. Now types of subquery, there are two. Okay, one is single row subquery which just returns one row, okay, or just one value. There can be multiple row subqueries where we get multiple values. Okay, we get multiple values. So if you remember, what do we use for multiple values? If we have a list of multiple values and I want whatever filter I'm putting, it should be in either of the values, then it's fine. We use in clause, if you remember. So single row subqueries, it returns only one row. Use single row comparison. Okay, let's have a look into executing single row subqueries. Okay, so what are we doing here is select last name, job ID, salary from employees, where job ID is equal to select job ID from employees where employee ID is 141. Now, I am very much sure that, okay, 141 can occur only one time, once in my complete database. So obviously I'll get only one value out of this query, job ID, which is ST clerk. So I can have a single row subquery, which is equal to. So ST clerk and salary greater than, select salary for employees where employee ID is equal to 143. Now also I am again sure that because employee ID is a unique column or a primary key, so I know only one value will be returned from here, right, which is 2600, and I can very easily use a greater than operator, which is again a single row operator, right? Because we can't have multiple options on this end like 2600, 2700, right? We can't have it a greater, so we can use this. What we can also do is to, if you want for a single row subquery, we can use group functions. Okay, so when you group function without a column here, okay, on an overall group, you get a single value for sure, right? Minimum salary, you get a single salary. So here in this one, the question was get the data of all, get the data of the lowest paid employee. So what we did is, we can write salary is equal to minimum of salary, right? So what we did this instead, where salary is equal to select minimum salary from employees. Okay, now multiple row subqueries. Okay, what is multiple row subqueries? It returns more than one row and we use multiple row comparison operators. Okay, so here we have multiple. We have in, we have any, we have all. Okay, we have in any and all. Let's actually run through them. Okay, let's run the queries. So select last name, comma, job ID from employees where job ID is equal to, select job ID from employees where, okay, where employee ID is equal to 141. Okay, so what I did, I selected all the employees who are working in the same job ID of the employee 141. So from this, I took the job ID of the employee ID 141, and that is the job ID equated here. Okay, this was the question. This is again a single row query. Okay. Um, we will quickly see how can we use this subquery in a having clause. Okay, so let's do that. Let's have job ID and average of salary from HR employees. Fine. Group by job ID. So what I just did is I am selecting first. Let's see this. What I'm doing. I'm taking the minimum salary from HR employees where the department ID is equal to 50. So basically, I'm taking the minimum salary of department ID 50, and I am seeing for all the job IDs where the average salary is greater than the minimum salary. Okay, of the department ID 50, 19 rows, right? This is how you can use a subquery in the having clause as well. Always remember, even if it's a subquery, even if it's a filter, whatever it is, if you are using your grouped function column, you can't use it in a where clause. Always remember that. Okay. Next, we will see the multiple row subqueries. Okay. Hmm. So what do we have here? Select last name, salary department. Okay, so what did we do here? Let's first see what question it caters to. What we're actually doing is, first we're selecting all the minimum salary of each department. Okay, we are selecting the minimum salary of each department. After getting that, we are using those salary as a list, and this salary, whatever we are using here, this salary should be in any of the values we are getting from this list, right? That is why we have in. So instead of hard coding the values, we are just using a query, which is more better, and it is more dynamic, right? Sometimes we need to hard code values, yeah, that's fine, but then writing this kind of queries makes your query more dynamic, and wherever possible we should be using this type of queries. Okay, so this was in. Okay, next what we will see is any. Okay, so now what is any? Let's check that out. What happened? Okay, check out employees. Okay, so what happened here is, first we are selecting all the salaries, okay, from of the employees who work in IT program job ID, right? Now, what does any means? Let's see how many data are we getting here. We're getting 80 rows. And how, what if we do all? How many are we getting? We get 44 rows, okay. Now, what is the difference? See, hmm. So any is, okay. So if I write any, mm, mm, mm. if I write any, it means if I have three values, just think this data is returning me results, which is maybe 3,000, 4,000, and 5,000, for example. Okay, just imagine this is returning me data IT programming. The salaries in IT programming is 3,000, 4,000, 5,000. There are three people. I'm just assuming it for now. Now, when I say any, it means if the salary is less than any of them, okay, then it's fine. I'll take it. Which means the highest here is 5,000, right? So if I get a salary here, which is 4,500, that will be included in this result because it is less than any of them, right? 5,000, and the highest is 5,000. If there is a salary which is less than 5,000 in any of them, okay, we should get it. We are not comparing with each and every one of them. Okay, this is any. Now all. Now what is the use of all now? It means only if the salary is less than all of the salaries, which means the lowest is 3,000 here, right? So only if a salary which is less than the 3,000 value is, then when we get the row returned. That means 4,500 salary will not be returned when we are using all. Okay, only salaries which less than 3,000 is what will get returned. Remember this. All means this value should satisfy all the rows that we are getting. Any means if the conditions are satisfied with any of the value, then we are fine with it, right? So that is the difference between any and all. Okay. Okay. So okay, one last quick thing I want to show you. Okay. In Oracle, very specifically in Oracle, there is a table called as all tables. See, there are two kinds of tables which can happen. Okay, one is the system table, one is the user table. Now, system tables are tables which are created by the system and which contains the metadata about the system, right? System table contains the metadata about the system, or and the tables, right? So the details about the tables, okay, and details about other tables and everything is stored in table all tables. This is a metadata table. Okay, what is a metadata? It is data about your data, right? This we call. So now see, if we do a select star from all tables, right? So what do we get here? We get all the owner and we get the table name. Now let's just put here from all tables where table name is equal to employees. That is the table we used, right, throughout the course. Okay. Let's do this. Let's keep it here and put it like this. Or let me just put where owner is equal to. Okay. Why it didn't come as, you remember okay, why it didn't come as I put everything in small. It should be in capital. Okay, let me just put it HR here. Okay, see employees, it's in capital. So if I put this employees in capital, okay, let me comment this and run now. Okay, so I get this. Now, what does this contain? Let me just comment this and let's see if a few of the tables we have. So what does this contain? We have the owner. So you remember we were always doing HR dot employees, HR dot departments, because HR schema is the owner of this table employees or departments, right? That's why we were always writing HR. Without HR, our query wouldn't have understood where this employees is, because the same table employees can be there in multiple owners. Okay, so multiple schemas can have the same table. That's why we always had to specify which schema are we referring to or which owner are we referring to. Okay, so we have owner, we have table, okay, we have table space, and then we have various data about tables, right? Now this table is at the table level. So for each table we have one entry. We have another table with another system table which is called all tab calls or all tab columns. Okay, both are the same. Okay, all tab calls or all tab columns. Now what this will do is this is at the column level. Okay, so now if I comment this and just go for the employees table, I see all the columns for the employees. So for example, salary, the data type, and many other details about the column. So what is the length, what is the precision, what is the scale, okay, of the data, right? So we get everything here. Okay, so in this table we can see more about the tables. Okay, so you can use these tables at your own disposal. You can query these tables to know more about the columns. Okay, with this we end the course for SQL. I hope everyone has something to take away from this course. It could have helped you in your journey. Okay, there will be places where you might not have understood things. I would strongly suggest please Google out. You have plenty of resources, because Googling out is very important. I always encourage that. And please, if you don't understand yet, you can always revisit the recording, that part, and you can try out the the queries which we discussed, right? And see how it is working, and then you can try out various permutations, combinations, various types of values you can put, and then try out. And like I said, if you want, take a dump of the data like how I did in Excel, and then you can work out, right? You can also, in there are many SQL resources which are available. You can go, you can write the questions, and you can see how good you are and how much you need to improve, right? So please do that, and I wish you all the best for your endeavor, whatever you are doing, right? So that's an end from my side. Bye bye, take care.